Check, 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 check. Got anything? Awesome. Check, 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 check. Got anything? Awesome.
Check 1, 2. That's quite loud.
Hello. Wow, that was really low. Yeah. Really low. Hello. Welcome to JSConf. Can I get a show of hands who was here yesterday? Awesome. How did you like it? Are you still asleep? Did you have coffee? Okay, I guess you need more. That's fine though. Welcome to the third JSConf in 6 years here in Australia. This is the largest JSConf today here in Australia as well. And again, this is our attempt to challenge the quality of events that are being run in Australia and worldwide as well. We like to challenge the state of inclusion and diversity in the tech industry.
And however, microphone, hello. However, while we're globally focused, we're also here to acknowledge the custodians of this land, the Wurundjeri people of the Kulin Nation, and their elders past and present. I acknowledge and I respect their continuing culture and the contribution that they make to the life of the city and region.
Our goal has always been to build a series of events that are really amazing and that will expand your knowledge beyond what you know right now. But even more importantly, think about the human side of technology and what we do day-to-day basis at work or open source projects in our free time. And we are here for the bleeding edge experiments, for JavaScript architecture talks, ridiculous science, and challenging how the tech industry operates.
Don't like this. And to us and the entire amazing team that we have here, it's really important that everyone feels really welcome and included throughout everything that we do. We operate JSConf under a code of conduct, and this space and all of the parties and everything else inclusive of that is safe, and it's free of harassment as well, of any type. If you have any concerns at all about any of the actions or conduct of any of the attendees, speakers, or staff, refer to the website, and there's a full code of conduct there with reporting guidelines.
So JSConf, same as CSSConf, is a worldwide family of events, and we hold each other up to really high standards, and we try to do more every single year we run it. And that family is still expanding, which is something really exciting to see, so more people can attend in different countries and parts of the world. JSConf AU is not-for-profit, volunteer-run event, and it's really my pleasure, and please come to the stage, do an interpretive dance. Glenn, Jordan, Michael, this is Ben, Craig, because we wouldn't be able to do it if it wasn't for months and months of their hard work and sleepless nights and tremendous stress to host this event. Please give it up to them.
Okay, you're all great. You can leave for now. Thank you. Tremendous bunch of people there. So thank you, everyone. We have a professional photographer here. If you didn't already know, your lanyards are color-coded. So if you have a green or a blue one, that means photography is okay. If you have a black one, it means please ask before taking a photo of this person. And if you have a red one, it means please don't take photos of this person. Our photographer you may see our photographer's lens pointing at your way, but don't worry, even if a photo is taken, we will never publish those if you're wearing a red one. Oh, I've completely broken my own computer. Okay, that's good. A little bit of housekeeping. We're live streaming this. This right now is on the internet. We've got people all over the world catching it in Europe and through the US, and so for our speakers, that's a pretty cool thing because if there's friends or family that are back on the other side of the world, Australia's pretty far, they can follow along too. You also may notice that we have live streaming in the far end at the beanbag area, so if you're feeling a little bit low energy or you just want to be a little bit quiet, you can go down there and hang out. It's pretty cool. The official hashtag is JSConfAU16. So if you have any photos that you want to share or thoughts or anything like that, and also we want to hear from you. So if you think you're having the best day ever, definitely tell us that. If you're not, we want to know about that too. For bathrooms, there are bathrooms over in the right-hand side, just past the coffee area. If you are a smoker, please don't smoke on the street side of the venue. Please go out to the garden, which is just where the bathrooms are, except you just keep going and you head outside. There's a little area where you can hang out. It's actually much nicer than the street. We have amazing meals, coffee and tea here today. They cover all of the diets, so if you told us about your diet, you're definitely covered. Food's delicious. It was pretty good yesterday. Clap if you enjoyed food yesterday. Right? So if you weren't here yesterday, it's all right, yeah. We've got really great coffee from Everyday Coffee. We also, if you haven't noticed, they have some little bags there that are branded, and they're limited edition bags for JSConf, CSSConf, and Decompress. So you can pick one of those up. It's just a retail bag, so I don't know what they cost, but they're great. We have morning tea, we have lunch, we have afternoon tea. We have a great party tonight too, which is here, so stick around for that. Oh, and an important part of partying is that you should be able to greet each other in a way that is close to our hearts, right? So I just want to, I'm going to give you a little demo of something. If you're, maybe you're greeting someone for the first time, or you're seeing a really good friend, this is what I want you to do. Can I have some help here from somebody? Anybody ready to help me? All right, this is a Top Gun high five. We do that every day. Don't forget, everything we do here, we do it for you. So have a really, really good day. I'm going to spend just a quick second to introduce our first speaker. His name is Justin Falcone. He's a Brooklyn resident, so he's come here all the way from New York, and he's going to talk about HyperCard, the bicycle for mine. Justin, come on. Give him a really warm welcome.
Plugging in sound, think good? Good morning. All right. So what is it that we like about computers? How did we all come to fall in love with them? I think we've all got stories, right? For some people it was the first time they saw desktop publishing. They realized that you could make a magazine because you cared about design and writing, not paper and glue. For some people it was the first time they played a video game. They realized, oh, in this tiny little machine, there's a whole world inside here. And we're lucky few of us who've been on cyberspace. We've had the experience of oh, I just sent somebody an email on the other side of the world, and it got to them instantaneously. It's an incredible sensation. The running theme in all these is in these origin stories is how computers, they empower people by removing physical constraints. They let us live in this Willy Wonka land of pure imagination. And this is software at its finest. This is why Steve Jobs calls the personal computer the bicycle for the mind. But all these share a fundamental limitation. We, the programmers, we sing these worlds into existence for users to inhabit. But the users, they can't really go beyond what we give them. There's this gap between using and programming. Now this is my origin story. This is how I came to love computers. I think I'm talking to programmers. I think that we all have a first program, something along these lines. But if we want to go from printing butts forever to actually making the software, well, you remember what that was like. It's a process. I mean, so when somebody comes in and say, I want to make my own software, well, what's the next step after this? And believe it or not, this is a huge advancement over what home computer programming was like even 10 years ago. This is worlds away from like writing 6502 assembler. But most of us, we've all had to deal with something like this, but this is just insurmountably arcane for most people. Now, it reminds me of this cartoon, How to Draw an Owl. But this is, honestly, if this was what programming was like, programming is even worse than this, because I can't draw a beautiful owl, but I can draw this, this thing that looks kind of like a parakeet. And you might not be able to draw a beautiful owl, but you can still draw a recognizable, if kind of shitty one. Now for most people, these drawing skills, these are sufficient. These are useful. Even if we can't draw this beautiful owl, we can draw diagrams and maps and this cool-looking S. I wrote a pretty dire novel in my early 20s, but I'm still fairly confident in my ability to write shopping lists and thank you notes and code. Nobody's going to say that I'm illiterate because I wrote a thinly veiled memoir instead of the novel I thought I was doing. A handful of us will go on to draw owls the right way and write real novels, but we don't claim that only novelists are literate. But for some reason, programming is treated differently. Most of our tools, they're not designed for shitty owls and shopping lists. And our culture expects people to learn how to draw without ever learning how to doodle. I wonder if this is because a big part of our culture wants programming to be hard, wants us to be like this elite class. We view any tools that claim to make programming easier with suspicion. It's that's not real programming. That's dumbing it down. This is you can do this, but this is for noobs. People haven't paid their dues. We all want to believe that we're these perfectly rational iconoclasts, but we're desperate to find any orthodoxy to cling on to and just use it as a cudgel against anything that's actually new. I can't help but see this facet of our culture is it's like schoolboys who are perpetuating these generations-old hazing rituals. But no matter what we do, we look up to Dijkstra and he just glowers back at us. And he's still disappointed that we're not writing formal proofs of our programs. So how do we bridge the gap between users and programmers? Now there's two sides to this. One that's technological, one that's more cultural. Now, on the tech side, I'm going to talk about a tool called HyperCard. First, what it looks like today, and second, what it could look like what it can lead to in 2016, 25 years from now. Then we'll look at the harder part, the ways that our culture will need to change in order to get from here to there and fulfill the promise of a bicycle for the mind. So, HyperCard, it's a tool for building simple programs that use cards and stacks as the central metaphor. So the presentation I'm giving, that's a stack. These buttons on the bottom row here, these are links to other cards in the stack. And these icons here, these are links to other stacks. A lot of the, this is one of the example stacks that comes with HyperCard. Most of the example stacks end up being basically just fancy databases, or databases with a nice UI. But it turns out a lot of software is just databases with a nice UI. And you can just go through pages. The interesting thing here is there's no distinction between, there's no data side and presentation side. Any output field is also an input field. This has some obvious weaknesses for programmers if you're thinking about this from abstraction purposes, but it's really hard to beat for simplicity. And you can insert a new card. I'm just going to put in I'm not going to put in my actual address because this is I don't want to get junk mail. But and it just uses all the cards can share a background. So if we go into the background mode, you see the little stripes here. That's now this is the shared background used by all the cards. or the cards in this section. So this is the primary system of abstraction in HyperCard. Now I'm going to redesign this, or I'm going to redesign this in fast motion. It's actually quite tedious to watch this in real time. It's a lot more fun to do. But yeah, you can change the background, rearrange all the icons or in the fields, and it doesn't, all the data updates to match it. So now, yeah, layout has changed, the content remains. We can add some stuff to the foreground. So let's make a button that links back to the presentation. There you go. I'm very fast at typing. There we go. Now, did we just program? We built software, but we didn't code anything. Now, HyperCard, it actually does have a programming language built into it called HyperTalk, but so on here, we've got this here. This just like hides the menu bar in the tool window when I open up the stack, so it's more presentation-y. And then this block of code here, this is so it works with my presentation remote. But I need to write this code because I've been doing some fancy stuff, but this is not an essential part of the hypermedia authoring experience. You don't need to do this to be productive. I mean, also, just an aside, I really like how they handle the event handlers here. I hope somebody copies that. Even if you end up writing a little bit of code, you don't have to write a lot of it. It's HyperCard. What it does is it blurs lines between programs and documents, between databases and UIs, and most importantly between programmers and users. But now what it could be. So HyperCard, it's not perfect. It's Mac only. It costs kind of a lot of money. It has some pretty severe limitations to the programming environment. I don't really have time to get into specifics, but natural language programming, I think, is the advantages of having English-like syntax is overrated. Also, HyperCard doesn't have any data structures. Everything is a string, but don't worry about that. The important thing is that it proves that hypermedia can work in the real world on real home computers. You don't need every hypermedia system before this has been some experimental thing that was done at a university or in a lab, and it's well, this could work on if everybody has these $70,000 Xerox Altos. However, but I'm really excited about where HyperCard and its successors can go in the future. So let's explore that future. So what will hypermedia look like in 25 years? Now, again, the technology side, we can bet pretty confidently that computers are going to be much faster, much more powerful, and the information superhighway is going to be faster and more widely available. But we need a little more, vision to imagine a world where there's with reduced barriers between users and programmers. So for the future technology side, is I want to answer how will today's users become tomorrow's hypermedia authors, and how will today's programmers, us, how will we empower them? Now, when we look at the other user-friendly programming environment, spreadsheets. We see a few key characteristics. One, they allow direct manipulation. There's no separate data and presentation modes. It's all what you see is what you get. That direct manipulation enables non-programmers to explore. If you want to try something out, you don't need to convince a programmer to build it for you. You can just do it yourself. And this then means that programs can be transient, because the program isn't a product. It's an artifact of the exploration process. It's like having a sketch or a study for an artist. Now, but even when your tools enable rapid development, distribution challenges can force to be slow and ponderous. So Excel and HyperCard, they can make it very easy for an individual to sketch software out for themselves, but distribution still involves getting boxes with disks into stores, and that's still real time and real money, and which really limits your limits your space for experimentation, fluff. Now, I think this is really apparent in the packaged hypermedia-based software you see today. So For some reason, HyperCard's niche has become this extremely high culture educational software. So this is Beethoven's Ninth Symphony CD companion, and it walks you through all the in here it's talking about sonata form and how it relates to the Ninth Symphony. And don't get me wrong, it's excellent software, but it's not representative of the kind that everybody's going to be writing. I mean, not everything we make has to be a monument. Now, if we put hypermedia on the internet, then the distribution problems kind of fall by the wayside. Now software travels from my computer to yours at the speed of light, modulo how fast a 9600 baud modem can decode. But freed from the burden of permanence, what could hypermedia-based software look like? Well, I would expect a lot of the people making traditional media today will be making hypermedia tomorrow. And a lot of what we do today with newspapers and magazines and alternative weeklies and stuff, those would be a natural fit for hypermedia. HyperCard's currently HyperCard's tools for layout and content management are not particularly sophisticated. They're honestly a little primitive, but I can only imagine that as they mature, they'll become as sophisticated as anything that you'd see in desktop publishing, in Quark or in PageMaker. There's no way we're going to regress on this front. I mean, can you imagine if we needed a programmer to move something over 3 pixels? Now, if we focus more on the exploratory angle, hypermedia could be the basis of new tools for thought, new brainstorming, mind mapping, that sort of thing. A lot of the early visions of hypermedia, going all the way back to the Memex in 1944 in Vannevar Bush's article, As We May Think. This is exactly what they were. They're systems for academic research. Now, scholarly works, for example, they could show analysis and primary sources side by side, allowing you to make direct connections between the ideas and their context. Now, this could be useful, both for the researcher organizing their thoughts as they write the analysis, as well as those who study it down the line. But that has some obvious implications for journalists, too. I mean, imagine if every fact cited in a news story could be linked back to its source with annotations explaining the relevance. I mean, the global hypermedia network, it could usher in a new era of informed audiences and maybe even voters. Now, I don't want to focus entirely on work. Now, empowering users, we are not our jobs. It goes beyond helping you do your work. Hypermedia can help your life. It can help us with self-expression and exploration. Now, the cynics in the audience are probably saying, well, yeah, this was the same promise of desktop publishing too. But as I mentioned before, desktop publishing it's kind of a misnomer. It's desktop page layout, but the publishing still has to go to a service bureau for printing. It's making page layout accessible does not solve the distribution challenges. But with hypermedia, but with over the internet, a global hypermedia network makes personal publishing truly accessible. Now, we won't all be members of the professional media, but perhaps we'll be able to participate in a new kind of social media. So the other question I posed was, how will today's programmers empower the hypermedia authors? I see our work in the future to be a lot like the role of hardware and system software today. We're providing the infrastructure that all of this depends on. We are the substrate. And we're going to be building the tools that hypermedia authors use, the low-level primitives and the widgets that they use to compose their work. Right now, a lot of this comes from first parties. So in addition to HyperCard itself and the HyperTalk language, Apple provides a whole bunch of ready-made buttons and fields and stuff. This is what I guess you would think of as HyperCard's standard library. On a side note, they also provide some fantastic clip art. It's not all animals using Apple computers, but there's a lot of that. But first parties can't provide everything. There's a small community of third-party widget makers today, but as the world becomes more connected, this community is going to eclipse and eventually dwarf the first-party contributions. Now, all of these people sharing these widgets, they form an ecosystem. All the individual components become connected and support each other as a whole. I like to think of this as asynchronous collaboration, where people who've never met nevertheless become interdependent on each other's code. Now, it's important to realize that the ecosystem is going to need to work at both ends, publishing and consuming, for people with a wide range of abilities. The way we imagine this may be that the author is going to be using the widgets and the programmers are going to be making them, but the inverse is going to be true as well. Programmers are going to want to use the ecosystem for their own projects, sharing code, and authors are going to want to share widgets that they've modified or composed from smaller pieces. So it's important that these users will have different needs and workflows, but still have the same goals, and we need to accommodate that. And also, the unit of abstraction isn't necessarily going to be as small as widgets. Sometimes common workflows and widget collections will aggregate into frameworks. Knowledge bases and online magazines and adventure games, they all work pretty well within the rubric of hypermedia, but each has a specific set of needs, and these groups are going to develop their own standards and ecosystems, even like social mores within those of hypermedia as a whole. So this widget and framework ecosystem, these are going to be an on-ramp into traditional programming for a lot of people as they move from doing little bits of scripting here and there to writing business logic to actually modifying the core of the projects that they're using on. If there's any one thing that I think is going to bridge the gap between users and programmers, this is it. And now the hard part, what we need to change in our culture to enable this growth. So as I was researching the history of hypermedia, I noticed a common theme running through the foundational text, a sense of responsibility. As we may think, Vannevar Bush he was actually on the Manhattan Project, and he was writing this as he was developing the atomic bomb, and he was thinking about he was trying to come to terms with how much of his work during the war had been he had been making weapons. And he was by no means a pacifist, but he understood that his work was not neutral. He saw that building weapons, was his responsibility in wartime, and in peacetime, healing the world was his responsibility. But we as programmers, we don't talk a lot about our responsibility. I mean, we're not making atomic bombs, but we can't look at how much everything has changed in the 70s and 80s and act like that, we're not making an impact. Some of it's good, some of it's bad, but none of it is value neutral. And while our world is becoming increasingly dependent on software, the creation of that software isn't becoming democratized. If anything, it's heading towards oligarchy. As programming becomes more and more of an elite and credentialed field. The software industry, it seems to be recapitulating the excesses of the Gilded Age, only with technology as the lever of class stratification instead of railroads and oil. Now, a lot of you are probably saying, well, I didn't create this world. We didn't start the fire. It was always burning since the world's been turning. And you're right, but it's not about guilt or who started it. It's that we're all parts of this machine now, and we participate in its operation. Unless we are actively fighting against it, we are, in some ways, supporting it. We support this system when we abdicate our agency, when we write software that harms our users because it's just a job. We support the system in the work we choose not to do when we decide that nobody really needs hooks for accessibility or customization or composability. Those are, empowering users, that's not providing business value. And we support this system with the teams that we build. We're all familiar with the phenomena of hiring managers saying, you don't actually need to know anything about the banking industry. You'll learn the business on the job, immediately followed by 5 years C++ experience required. Then we act all surprised that we've got these teams full of people who think like us and act like us and, let's face it, look like us. So I keep coming back to this notion of a bicycle for the mind. So here's the full quote. This is Steve Jobs. I read a study that measured the efficiency of locomotion for various species on the planet. The condor used the least least energy to move a kilometer. Humans came in with a rather unimpressive showing about a third of the way down the list. That didn't look so good, but then somebody at Scientific American had the insight to test the efficiency of locomotion for a man on a bicycle, and a man on a bicycle blew the condor away. That's what a computer is to me. The computer is the most remarkable tool that we've ever come up with. It's the equivalent of a bicycle for our minds. Now, this speaks to me on a couple of levels. I mean, not only is the bicycle a tool that increases human ability, but it's a fundamentally democratic one, too. I mean, you can sink a lot of money into a nice bike, but even a cheap single-speed Huffy will get you around. It's a machine that is eminently fixable and understandable, suitable for children at play and adults at work. The computers we have today are not bicycles. Instead, we've got something more like, a car for the mind, which, it gets you around. It's easier and more comfortable than a bike, but at what cost? When America decided that it was going to be a place for cars, we signed ourselves up for urban sprawl and air pollution and car crashes and oil wars. Even on a human scale, cars are as much liabilities as they are assets. I mean, I'm sure we all know people who are working terrible jobs to keep their junker car running so they can get to their terrible job. Now, what happens if we go on with our lives without taking responsibility? Let's suppose that technology changes as dramatically as I'm predicting here, but our fundamental culture remains the same. Well, I see a world in which computers are 1,000 times more powerful than today, and they fit inside your pocket. But the tools for building software are the same arcane text editors we've been using since the 70s. I see a tech industry serving a generation that grew up with computers and understands them intuitively, distributed all over the globe, and yet the industry itself is like some kind of nerd country club with disposable immigrant labor at the bottom, vampire billionaires at the top, and for some reason, everybody has to relocate to San Francisco. Now, in my darkest moments, I see a world where everyone is constantly connected to a global hypermedia network, where every movement is tracked, every behavior is analyzed, so advertisers can better deceive us. That's where we're headed. But we can change direction. Even if we're still on this trajectory in 2016, we can still change. The history of computing is filled with small teams having huge impact. The entire Xerox PARC organization could fit inside this room. The first version of HyperCard was made by a team of 5 people. For all we know, the technology that dominates the next 25 years could be, a documentation project at a European particle accelerator. These innovations are as much cultural as they are technological. I mean, the systems designed at Xerox were marvels of engineering, but it's not the code that endures. Their legacy is a culture of user research and humane design. And culture is not an artifact. It's a process that needs to be enacted. It needs to be embodied. We all know how groundbreaking new technology can struggle in the face of misunderstanding and dismissal and fear, uncertainty, and doubt. Just imagine how much pushback new cultural concepts must necessarily get. It's our responsibility to recognize, adopt, and evangelize new social mores with the same enthusiasm and tenacity as we do with new tech. I presented you 2 visions of the future. One where we build a global hypermedia network to bring the power of programming to ordinary people, and one in which we use it to make some rich guys even richer. The basic technology is the same. All the difference lies in how we choose to use it. Thank you.
Thanks, Justin. I held the microphone too close to my mouth. You think I know how to do this better? I need to do it 84 times. You're about to get introduced to Jess Telford. He's a Sydney-based developer who I've been lucky enough to work with once a month as we set up the React Sydney group. Before that, he was running the Sydney Developer Drinks group, which is something I had in my heart a very long time ago. But Jess is a developer that helps me to remember that being a developer isn't just about writing code. He's developed, obviously, his own personal brand. He's developing communities through his work with React Sydney. He's developing a great team at Domain where he works. And hopefully today he's going to develop a little bit more of your imagination with his introduction to Pokemon. Please welcome Jess to the stage.
All right. Thank you very much, Craig. I really appreciate the intro. My name is Jess, and I will get some slides up for you to look at instead of that lovely background. Alrighty. There you go. And then Excellent. So you can find me on the internet at Jess Telford, pretty much everywhere. I try to, like Shaq said, or Craig said, I try to keep my brand pretty simple. It's my name. If you want to follow along that's the link to the slides. They're available. They'll be available after the talk. They're not available right now. And so what I wanted to do was give you a little bit of an intro into myself before we talk a bit more about the topic that I'm sure you've read the title of. So I built my first website in 2005, I believe it was. It's going back a little while now. I spent the last 2 years as the team lead at domain.com.au. We've grown an excellent, large front-end team there. We're building things in React and all sorts of really cool technology. I like to keep my hand in where I can in some fun new stuff, and so you'll see some of that today. Today is the first talk that I've been able to give since my son was born a little over a year ago. And so in his honor, I wanted to start with a dad joke. Hope that's okay. So two whales are sitting in a bar. One turns to the other and he says, Second one turns to the first and says, "Go home, Sam, you're drunk." All right, cool. So we're all listened up a little bit now. So I'm going to be talking about building Pokemon Go in 100% JS. So I'll start out by saying I'm not affiliated with Niantic. Pokemon Go is their own registered trademark. But I wanted to use them as an excellent example of what you can build today with technology. And I wanted to talk a little bit about how we can build that in JavaScript. As well as my website experience, I've got experience building games. Back in 2009, I built an augmented reality game for the Nintendo DS with a local Sydney-based startup. Since about 1998, I've been dabbling in making games. So this is kind of like a good cross-section of my passions of building websites, JavaScript, with building augmented reality and games as well. So a more accurate title for my talk is how to build a 3D location-aware, offline-first, monster-catching, massively multiplayer online game with shared world and augmented reality in your browser today. Catchy, right? So that's why I didn't go with that title on the program. So let's start with talking about 3D in the browser. So 3D in the browser, as you may or may not be aware, is possible with WebGL today. WebGL is based on the OpenGL standard that is common with games, and any game developer that's been building 3D games recently will know it and be able to transfer those skills to the web. Unfortunately, a lot of web developers don't know those 3D skills, so it's quite tricky to get broken in. One of the interesting things that's come out of the JavaScript scene is 3JS. It allows you to do much simpler OpenGL or WebGL programming. But it could be even easier. So A-Frame has come along. A-Frame is developed by Mozilla. It's based on the WebVR spec, and you'll hear a little bit more about the WebVR spec this afternoon. I'm really looking forward to that talk. It's going to be great. I won't touch too much on those details today, but basically A-Frame allows you to take the best parts of 3JS and implement that in the browser with some fairly simple markup. So what we'll do is we'll jump into a demo. Now, hopefully this will work. Okay, cool. So what you see here is a very basic 3D scene. There's a background, and there's a blue box and a red sphere. This is all in A-Frame. Traditionally in OpenGL, there would have been lots of fun stuff with loading textures and worrying about positioning of the elements and all of that kind of stuff. But thankfully, with A-Frame, that all boils down to this. So we set up a scene, which has a box, an A-frame, they prefix everything to A. You give it a position, some dimensions, a color. Same with the sphere for the ball, and the sky for loading the texture. So it's actually fairly compact, that set of code. I won't say it's easy because it actually took me quite a while to get my head around how this actually works myself, but the documentations for A-frame are quite good. That was a very basic example. It doesn't take control of, so this can also run in a browser, by the way, on a device, so on a mobile device. It doesn't take control of the tilt sensors or the gyroscope and accelerometer and those kinds of things that you have in modern devices. So what we can do is we can add one extra little line of code there, which is the A camera, and then we can enable look controls on that. So that allows us to take control of the, on our device, of the gyroscope and tilt sensor. So I'm going to try and load up a demo on my phone. Hopefully this works. Excellent. So you can see here, looks like the streaming's going a little bit slow there, but you get the basic idea that as I tilt and rotate the device, then the display updates and it correctly rotates the camera so we can see different perspectives of the 3D scene. So that's a very basic demo of using the motion sensors that A-Frame gives us with that one line of code. So let's move on to catching monsters. So this is where we get into actually making a game rather than looking at just that very simple scene. So what we want to do is we want to make the scene interactive. And so what we can do is with this demo, and hopefully this one will work a little bit better as I open this up. Once again, bear with me for 1 second. Okay, so we've got let's find where the box is gone. Oh no, it's loading. Okay, so what we might be able to see here is, it's quite delayed unfortunately, but I'm moving the sphere around on the screen by dragging my thumb. So you're able to see that you're able to interact with the 3D scene by the 2D screen. So I can throw the ball and it'll land on the ground and roll away. So that's quite nice. And so using that mechanism, for those familiar with the game Pokemon Go, we're able to then actually catch monsters by throwing a ball at them. So how did we do this? We set up physics in the scene. That very first line, the A scene physics, sets that up for us. We set a static body. That's the ground would be the body there, the static body for collision, so that when we throw the ball, it doesn't infinitely drop down into nothingness. And then on the sphere there, we added the click and drag option. It looks like an HTML attribute, but it's very similar to a React component where it has its own lifecycle hooks. This is all part of A-Frame still. And then we've also set a mass on that so that it reacts to gravity and those kinds of things, which is really nice. So you can kind of start to see here how powerful A-Frame can be and how few lines of code it will take to build up a 3D scene that's interactive and that we can start playing around with. I should note behind the scenes there is a lot of JavaScript powering this, but this is what you end up as the end user developer creating. So moving on to location-aware. So this is fun. I've always had a passion for location-aware games. I used to play a few geocaching and those kinds of games, early user of Foursquare and that kind of stuff. It's always a bit of fun. We need to display things on a map when we're doing location-aware stuff. We're familiar with the popular maps, Google, Apple Maps. There's a little less known one, OpenStreetMap. That is a free open source data set that anybody can use to render their maps. But then we need to render them somehow. So Google and Apple have their own rendering engine. That's what you see. They're often called slippy maps. They slip around under the finger as you're touching and dragging or you're zooming. They kind of slip and slide. So there's a few slippy map rendering options. Leaflet.js is quite a popular one. It recently went 1.0 after a few years of it being in 0.x. So that's really great for them. Mapbox is another excellent one. Mapbox is the one that I've chosen to demo today. They use WebGL under the hood for doing rendering, which is really nice. It's quite performant on modern devices. And they they allow you to style the maps quite easily. So you can set up a JSON object and change the color and outlines of roads and parks and those kinds of things. So we'll load up another demo here. Hopefully this will load. Sorry, it's using my tethered internet connection. So there we go. So we can see that it's loaded up. This is just a very basic map demo. You can click and drag around. You can zoom and do all those kinds of things. So that's Mapbox.gl. The way we do that is by instantiating a new instance of mapbox.gl.map. That allows us to then display the map. And I've added a little bit extra code there which gets the geolocation of the user. So it uses the navigator.geolocation.watchPosition function. This is available in all modern browsers. This allows you to get the GPS location of the current device. There is some interesting points here. So the enable high accuracy down the bottom, that's one of the options you're able to pass in. That hooks into the GPS device rather than trying to use the Wi-Fi to guesstimate the current location. It's very useful for handheld devices, but it can chew through the battery, so be aware. And then you can see that we are accessing the latitude and longitude from the results that it gives us back. So that's great, so that's a 2D map, but now what we want to do is render that in 3D. So what we do is take that same map that was rendered and we drop it into a 3D A-frame scene. You can see here as the map will load into that space. It is in Melbourne, that's great. It's found us, which is cool. We've dropped a little sphere on that location, and you can see we're in 3D here. So I can move around and look at the map. So that's pretty cool. So now we're able to render a map in 3D for our location-aware game. And this is how we've done it. So we've replaced the instance of the map.gl object at the top with an A map element there. And then we've done the same watch position, geolocation.watch position, and grabbed the latitude and longitude. And this time we've injected that into the A map as an attribute using mapl.set attribute there. And we've enabled the same high accuracy things. So that's where we set the center of the map. So this allows us, again, in quite a few lines of code, in a small number of lines of code, we are able to render a map in 3D and set its location based on where the user currently is. So that's cool. That's good fun. We can do that rendering now. Now we want to make it a little bit interactive with the world. So we want to have item drop locations. Pokemon Go calls these Pokestops. It's where you might find items that you can use throughout the rest of the game. So it's interesting when we do this. You can have a game that does this kind of stuff. It can generate items and you can find them, and it can be random, it doesn't matter. But when you're talking about a massively multiplayer online game, those items that get generated, they should be persistent between users. They should be in a persistent location. If I'm playing the game and I'm standing next to my friend who is also playing the game, if they see a location that's 10 meters away and I see one 100 meters away, it's confusing. It removes the social aspect of the game. There's no way to say, hey mate, over there 100 meters is a spot where you can find items. So we need a way to be able to get a consistent set of locations, something that is maybe related to landmarks, or it's something that might be somewhere that's popular nearby. Foursquare has a lot of this data. Foursquare is excellent for this. So they have crowdsourced data over many, many years. They provide excellent APIs as well with very generous rate limits. So we're able to access that data and load that up, and it'll be the same across users for subsequent API requests. How do we do that? So we make a fetch request out to Foursquare. Here we can see that we are using the HTML5, the new fetch spec. That's very similar to AJAX requests for those that are more familiar. And we give it the result down the very bottom there is a set of venues, and that's what we're interested in. To do the search, we give it a bounding box, and we give it this northeast and southwest bounding box, given the lats and longs. There are other ways to search. You could do a location plus radius. But doing this way allows us to chunk up the location of the world. We're able to say, okay, the world consists of small boxes, and in those boxes are these locations that we're looking for. If we did radius and position, just the matter of stepping to the side by 1 meter would change my position, so I'd have to do another search in that radius. But by doing a bounding box, as long as I'm still within that box, I can continue to get the same results, so I don't need to research again. So that's a little bit of an optimization technique that we can use there. Then what do we do with those locations once we've got them? Well, we want to drop them on the map. So we do something like this demo. This is another 3D demo, and it will show a 3D space, 3D map. This is our location, and here are some of the locations that are returned from Foursquare. So we can see that we've got maybe 15 or so there. It's possible right in the CBD to get a couple of hundred from Foursquare. There's a lot of venues nearby. So you might have seen on the previous slide that we had a limit of 50 items, just so that we don't overload the user. And this is roughly what it will look like when we're dropping the pins on the map. We create a cone, it's inverted, and we give it a position. They would be dynamically inserted into the DOM, but this is an example of what the DOM would look like after we've inserted a few locations. And this isn't limited to just venues as well. So we don't have to just use Foursquare for venues. We could use any kind of location information. For example, if we're hunting monsters and we want to know where the current monsters are and we want that to be shared, that could be behind an API as well. So speaking of shared, this is where the massively multiplayer online part comes in, where you want that shared world. What we want is some way to be able to consistently retrieve that data for our users. And so the best way to do that is to set up our own server, and we can do that in JavaScript as well. So we set that up with Node, and this is a very simple Express app. This is the Hello World from their help pages. I won't go into details on how Express works, but essentially this accepts HTTP requests and returns a response, in this case hello world, but we could just as easily return location data for monsters or for venues and those kinds of things. What we need to do though is store that data. We need to store the location information, the venues or the monsters, in some way that's easily searchable for us. We need some way to be able to do geospatial searching. And a great tool that's also powerable by JavaScript is MongoDB, and that supports geospatial searching. So with the geospatial searching, you're able to do these kinds of queries that, in this case, we say a point has a location, it's a Latin long, and then we want to search within a max distance of, that's 5,000 meters from that point. So here we would get back all of the locations that we have previously stored. So we would still have to do a request out to Foursquare to get the initial data, seed that into the database, and then make such a request on every user request. We can do this for the monsters and stuff as well. This is all great. This is, actually, before I move on, this is a point and a distance. MongoDB also supports the ability to search by bounding box. So we mentioned before the northeast and the southwest kind of boxes. We could also search by random polygons. So as long as you have the outline of, say, a suburb or a country, then you're able to search for every item that fits exactly within that outline, whether it's very complicated or whether it's a circle. It's indifferent. So this is all well and good when we're playing online, when we are connected to the internet. When we have a good, stable 4G connection, we can pull down all of this data and render that into our game. But what about when we're offline? That's when we need to start thinking about what's known as progressive web apps. Progressive web apps also cover a bunch of other areas, so talking about the speed of the page that loads, not just the offline, things like push notifications, being able to go full screen, a couple of other bits and pieces. But one of the largest parts is being able to load offline, progressively being able to load the page no matter what your internet connection looks like. Internet is really unreliable. We're after an app-like experience here. I really enjoy this site. This is by, where's my mouse? So this is a page, everyone has JavaScript, right? This is by Stuart Langridge, aka @Sil. When a user request comes in, has the page loaded? Well, no, because do they have JavaScript? No, they don't, because the page hasn't loaded yet. Did the request for the JavaScript succeed? Maybe not. Maybe you went through a tunnel, or your connection randomly dropped out. Did the HTTP request actually complete? Did we get all the data back for the same reasons? It could just drop out halfway through the request. Does a corporate firewall block, or does your country's firewall block JavaScript? It's entirely possible, and it does happen often. So if all of these things happen, there's a bunch of other situations where it could go on. Is the CDN up? No, it's down. Can I use? Okay, the JavaScript doesn't support the JavaScript. The browser doesn't support the JavaScript you're trying to load. If all the above is true, then yes, JavaScript works. Probably. Maybe there was an error thrown in your JS, and it killed the rest of the execution. There's all sorts of weird things that can go on. So if you can protect against as much of this as possible by loading it once early on in a good known state, and then enabling that to load when they're offline, then all the better. How do we do that? We do that with service workers. So service workers are excellent. They are the next evolution of app cache, for those who are familiar with trying to do offline in the past. So app cache allows, service workers allow you to basically do a threaded JavaScript execution. For those that are familiar with C# threads or Java and those kinds of things, it is very similar. It's a set of JavaScript that executes in parallel to your main page, and it listens to events. It also triggers its own events, so those two bits of JavaScript executing can talk to each other. The JavaScript that gets loaded in a service worker, it installs itself on the first page load, and then it's available to be executed on the next page load. So if you think about that, when you first access a web page, it'll install a service worker, and then the next time you reload that web page, it'll execute the service worker. Because you've hit the page the first time, you don't actually need to execute it. You've already downloaded the page. It's already running. So this is approximately what a service worker usage would look like. At the top, we've got how we would register the service worker using navigator.serviceWorker. We're able to do a really quick check to see if it's supported by the browser. If it's not, then we just don't use the service worker. The page will still work, just won't work offline. Once we've registered the service worker, in this case I've called it sw.js, then sw.js gets executed. So this is where it installs. So the install phase here happens on the very first time that the service worker is downloaded. And then on subsequent times, it can execute the fetch. So fetch there, it actually hooks into all of our AJAX requests that the main JavaScript thread runs. And we're able to do things like caching or serving from cache and those kinds of things. This enables, there's a bunch of other events that this does as well. And it enables some really complex patterns. These complex patterns can be helped a lot by these tools, by the Google team. So the first one, Service Worker Precache, allows you to, in your build time, determine which static assets might be available for the user, and then it will pre-cache those for the service worker. And the second one, the Service Worker Toolbox, allows you to do dynamic assets caching. So, for example, a API request. You might want to do that dynamically. You don't want to cache that at build time, so that's what that'll be used for. There are two prerequisites for using service workers. HTTPS. There's no technical reason not to use HTTPS anymore with things like Let's Encrypt. SSL certs are quite easy to obtain and use. And the other one is a manifest.json. Think of that like a package.json, but for your website. It has a name, it has a description, has an entry point, and a couple of other bits and pieces that are required for the browser to believe that, yes, this is an offline app. So let's get into augmented reality. Now, this is the fun part. So, virtual reality is really cool. We saw a little demo of that before where we were in a 3D scene and I was moving the device around and it tracked my motion. Pop that into a head-mounted display and you're fully immersed in this virtual world that we've created. What I really like, though, is augmented reality. Augmented reality says the environment around you is real enough. We don't need to create a new one, but maybe we want to add to it. Maybe we want to enhance it a little bit. Really good examples are heads-up displays. So if you played a first-person shooter game, the health bar and ammo and those kinds of things, that's augmenting the reality around you. Other ones might be, say, using maps and it's navigating and you have a head-mounted display on. You can look around in the real world, but it'll also drop, say, a pin for your destination, so you know you need to head in that direction. So they're really good things. We can do all that in JavaScript. I'm going to break it down into 3 parts, though. We'll go through them one by one. So to access the camera, we need to be able to do that to actually show the reality around us. We use get user media. So get user media can get both video and audio, which is quite good. It allows us to pause, play, stop, like any kind of media that we might play in a browser. It has a few quirks. When we call this, it will ask for permission from the user. The user then has to say OK or decline. If initially what you want to do is, say, display the rear-facing camera from a device when there's multiple cameras to select from, you might want to enumerate those devices first, and there is a command to do that. But if the user hasn't provided permission first, then the enumeration will return just an empty array, which is very confusing the first time you're coding this up. You're like, why aren't I getting this list of devices? You first need to ask for permission by executing get user media, then enumerate the devices, and then call get user media a second time with the device ID that you were actually after. There's a couple of gotchas there, but when it works really nicely. It's quite a simple API. So here's a demo of rendering video in 3D. Now hopefully this one will work, and it'll be a shot of my face if it loads, using the camera on my laptop. Yep, there we go. Cool, so we can see that there are two 3D objects in the scene and myself being shown on the video, and this is in fact a 3D space again, very similar to the one we saw before. So to do that, we use a very similar scene as before. This time we've added a camera, and a video billboard. So the video billboard basically calls get user media under the hood. And interestingly, what we need to do is, when you saw there, the video stayed static off to the side. But what we want to do is we want to say, okay, if that red area is the camera, and we're looking at something in the scene, which is the cylinder, then we want to be able to lock the video display to be where the camera can see. This is called the frustum, and we want to be able to lock it to that frustum. So what we can do is we can add this extra setting, this extra attribute there, frustum lock. And that will make sure that that video, it sticks to where you're looking in 3D. So what I'll try to do here is load another demo up onto my phone. Bear with me for one moment. Alrighty, and so you can see here that it's asking me to allow the usage of the camera. And so if I select allow, then it will start to load the camera. Unfortunately, the video streaming is a little bit slow. It looks much smoother on my device, but then we can also interact with the scene by grabbing the ball and, say, for example, throwing it around, same as we did before. Looks like the stream has stopped there. So that's an example of loading the video and using that as an augmented reality system, so we can display the 3D over the top of the videos. And that is how to build a 3D location-aware, offline-first, monster-catching, massively multiplayer online game with shared world and augmented reality in your browser. Thank you very much.
Thank you, Jess. I would like to run a little survey because before we have a coffee break. Who's here for the first time, first JSConf? Ooh. Who was here for the first JSConf ever in Australia? A few. Who is here for the JSConf in 2014? A few as well. Cool. In the case you were here yesterday, there were swag bags, but there are more swag bags, different ones today. So go to the swag table and get some goodies if you haven't done so yet. And now we'll have a little coffee break, so get your coffee, tea, soft drinks, and little snacks, and we will see you here at 11:40.
Hello, everyone. Hope you all enjoyed your delicious snack. We have a great lunch coming up after this. But next up, I want to introduce our next speaker, Emil. Our theme of this conference is social responsibility and technology we build. We saw that theme carry through to the first talk by Justin Falcone. And this talk's going to carry on some of that. It's going to be a much more technical talk, but it's going to show how we can use technology to bring abilities and freedoms to people who just don't have them for certain reasons. And Emil is not his first time in Australia. Actually, the first time he was here, he was surfing down in South Australia. Maybe his first time surfing and got caught in a tidal wave and then got bitten by a shark. So that's the story anyway. He was knocked out pretty hard. But let's try and make it a more friendlier time this year. So give a warm welcome to Emil, all the way from, I forgot, Denmark.
Is this on? Good day, JSConf. So, what happened here? Yep. What's that thing up the top? We'll see if it disappears. Yeah. I think this is good to go now. Yeah, I did.
Does it say it?
Oh, now it's back again. Okay. Yeah, okay, so we're good to go now. I'm here to talk about Hyperjournal. Hyperjournal is a tamper-proof publishing system. And what exactly that means, we're going to talk about now. So there's an issue here. Hyperjournal doesn't actually exist yet. So this is going to be how to build Hyperjournal, a tamper-proof publishing system. What we're going to talk about today is we're going to talk a lot about cryptography, and cryptography is very security sensitive. So if I say anything wrong, since we don't have Q&A here, you'll have to go and correct me on the Conf AU repository I put up. And also, if you're going to apply any of the ideas in this this presentation, go and have a look there before you actually use any of the stuff I'm talking about. Yeah, next warning. Doctors have the Hippocratic Oath, which is pretty much that you should always care for a person in need, regardless of whether they are able to compensate you. And pretty much every doctor in the whole world adheres to this oath. It goes all the way back to the ancient Greeks. In software development, we have a quite similar oath, and that's just don't roll your own cryptography. But yeah, we're gonna do some dangerous stuff here today. So I'm actually not sure what people say when they say don't roll your own cryptography. I think they mean that you shouldn't go and invent your own like crypto algorithms, but it doesn't really make sense if you can't go and use cryptography. So today we're only going to use cryptography. We're not going to invent any cryptography. So start with the narcissistic part. My name is Emil Bay. Online, I'm known as Emil Bayes because there's a famous mathematician called Thomas Bayes, and I want to associate with him. I used to study math at uni, but I was at the engineering school, but they didn't really teach it in an engineering way, so I didn't like it, and I ended up dropping out and just work on software. So I've worked at a high-performance computing lab with supercomputers, and I've worked at an advertisement agency, and most recently I've worked at a national newspaper in Copenhagen, Denmark. But now I'm working on a startup with a couple of other people called Commodity Trader, where we sell all kinds of agriculture products. So if you want to get hooked up with some Argentine high-protein soy, I'm totally your man, so just catch me in the break. Yeah, but really I'm just another hermite from the internet coming out of my shell today, here to talk about cryptography. Yeah, so what's up with Hyperjournal? What's this all about? Hyperjournal has a goal to provide a easy-to-use, cryptographically secure, integrated newsroom for distributed media organizations. So who are these distributed media organizations? And this is where all my motivation comes from. Comes from a project I've been working on with a couple of other people for the past maybe 9 months. We've been working with Syrian journalists in exile in Turkey. What we've been trying to do with them is we have 7 newspapers. They are all against the Assad regime. They're all against ISIS taking over Syria. They just want a peaceful, united Syria again. And to try and help that come along, we have helped them develop a digital media called SNP. These are the 7 media organizations. So that's been extremely interesting. That's been working on a Arabic news site, and I'll just tell you, RTL support in all the browsers is bomb, like shit. So these are the journalists, and you might not be able to tell, but this is life and death for them. Pretty much every single one of these people have gone through torture under the Assad regime, and now they're in Turkey. And the way they work is that they write their newspapers from Istanbul. They get their newspapers printed in Istanbul. They smuggle them across the border on big trucks, and they distribute free, so they don't earn any money at all. The way they survive is by doing a bit of freelancing work for Western media, and by the support they get from an organization called IMS, which is also the non-profit organization supporting all of this this work with SNP. Here's a couple of people I've been working with on it. So that's me over there, less bearded. And then we have Anders Emil and Jacob, and these are the guys who are working with the people in Syria. Now, these guys not in Syria, in Istanbul, they have the problem that they can't go and report from inside Syria, both because they might face imprisonment and torture, but also because the whole war in Syria is about who tells the story that the rest of the world believes, and it's very hard to get your story outside of Syria. I don't know this firsthand, but this is what they tell me, is that since Russia got involved in the conflict, this whole landscape of what's truth and what's false has become even more complex. So Anders is, I met Anders at the newspaper I worked at. He was the technical director there, and he asked me to come and work on this project, and I immediately said yes, because, I mean, in your life you need a profit project, something you can earn money from, but you also need a prosperity project, something that brings humanity forward. And this is, I think this is exactly one of those projects. But after we developed the website, he was asking me, is there no more, can we do something better? Because these websites that are against the Assad regime is extremely resourceful, also in technical regards. So anyone who goes against the regime, they'll get hacked, or attempted hacking. The Assad regime controls the whole telecommunications infrastructure inside Syria. So if they don't like your website, they might just use DNS poisoning to make people unable to access your website. I mean, Syria is not that's one thing people get wrong all the time, is that it's not a developing nation. People actually have high-end smartphones there, and laptops and desktop computers that are pretty much up to standard with what we had here 3 or 4 years ago, before the war broke out. So we were like, what can we do to alleviate all these problems? It all coincided with also reading this book called The New Digital Age, written by Eric Schmidt, chairman of Google, and Jared Cohen, the director of Google Ideas. And in here, they talk about how can we make a media organization in the 21st century that will, how can we use technology to actually empower media organizations. And one of the things they talk about in there is that connectivity gives a new hope to freedom of speech, because you can report from an area and the reporting is done. You might send your reporting outside of the area that's under pressure, and there's no way for the local people in power to take down whatever you're saying. But it requires a couple of things. Like, imagine there's an international NGO whose mission is to facilitate confidential reporting. We need that because we need someone outside the country who are not answering to local legislation. Fortunately, IMS, who I've been working with, are exactly that kind of NGO. So yeah, that's that. Next thing they say is that in order to protect the identity of the journalists, you need to register them in the system under just a number, like a code. So you can't associate their identity with who they are in the real world. And this code they talk about, that's something we'll call a public key in this talk, which is a part of a cryptographic technique. And so the journalists and the editors, they communicate anonymously, and they only have to meet ever once when they do the employment, and that's to exchange this unique number, which we call the public key. So, which problem do we want to solve again? We want to solve tamper-proof publishing, and especially over insecure channels. So what's an insecure channel? That's like, the internet is insecure. Carrier pigeons are insecure. Mail, telephone, everything is pretty much insecure until you establish a secure channel. So we'll use cryptography to do this. You can use cryptography to make secure channels, like we do it all the time with HTTPS. But since our problem here is that the internet might not be available in Syria, or like in this particular case, might not be available because it's controlled by one of the people we are fighting, we will have to go to other means. So the insecure channel might be carrier pigeons or USB sticks or Bluetooth networks or whatever. So to get started with cryptography, in cryptography we have something called ciphers, and ciphers is like the algorithms we use to do encryption and decryption, and it's defined like this. So we have an encryption function which takes a message, a plain text we call it, and it outputs a cipher text. You also have a decryption function which takes your ciphertext and makes it back into a plain text. And then you have some parameters, and some of them might be public, like which large prime number are we using, and some of them might be secret, like what's the key that we're using to encrypt with. So let's build our own first cipher. And so when you talk about ciphers, you talk about how much computational power do you need to crack the cipher, like who is your adversary. And this cipher we're going to build here has a threat model that says a determined fourth grader can break it. So you might be able to use it for sending notes in class, you might be able to use it to encrypt Christmas shopping list, or you might be able to use it to command legions across the Roman Empire. So, so this cipher was invented by Julius Caesar, and he used it 2,000 years ago to send military commands across the Roman Empire. And it's actually very simple. You might have invented this cipher yourself at some point. It's called a Caesar cipher. It's also called a shift cipher and a rotation cipher. What you do is that you take the alphabet, and then if you want to write A, you shift the alphabet over, and you might write C. So Caesar, he used the number 3. He shifted the whole alphabet by 3 letters. And this is actually the whole implementation for doing a Caesar cipher. You can see here that the encryption function takes in a plain text. The plain text in this case has to be a node buffer. I'll explain what a buffer is just in a minute. Then it takes every single byte in a buffer and it shifts it over. But the thing is with bytes is that they can only be values between 0 and 255. So what happens when we get to the last byte and we add 3 to it, then we get to like 258. And that's where we use modular arithmetic. I'll also explain what that is. Some people call it like clockwork arithmetic. So that'll just wrap the whole thing back around. So if you have 258, that'll wrap back around and become 2. Well, at least we can see it here. So quick intro to modular arithmetic. Clockwork arithmetic, because you can do it on a clock. A clock is like probably the most natural way where you learn modular arithmetic. Once the pointer arrow hand goes from 11 to 12, then from 12 to 1, there, you just rolled over from 12 to 1. It's all very natural. You also use it when you work with degrees or like time, of course, and GPS coordinates. Like the way I finally grokked what modular arithmetic was about was when I was building this robot game, and once the robots got to the edge of the game, I wanted them to go back to the other side of the map. And that's just taking the modular of the width of the map, so it will automatically always wrap around. A good way to think about it is rotation. So up the top we have 0. And this arithmetic we're doing here has a period of 3, so there's 3 values you can have. If you take 3 minus 1 modulo 3, then you get from 0 minus 1, then you're down to 2. And every time you take minus 1, you rotate anti-clockwise. And every time you go up 1, you go clockwise around. In in JavaScript, we have the percentage sign, and a lot of people call that the modulo operator, but that's wrong. It's called the remainder operator, so they're not exactly the same. Next thing, when you do cryptography, you're working with binary data all the time, so you use buffers. Who here knows what a buffer is? Okay, so good amount of people maybe. A buffer is just like it's just an array. It's just an array, but it's it's like the best thing we get to raw memory access in JavaScript. So you're actually going in and you're manipulating individual bytes in memory. In Node, it's backed by a typed array called uint8 array. It can take a byte in each cell, so a value from 0 to 255, and it's a default container. If you've worked with Node, you've touched buffers at some point, because every time you get an HTTP request, all the data that comes in is wrapped in a buffer, so you have to do like toString, and then you get what's the actual contents. We say that we have an array of individual bytes, and we make that a buffer. And the last one is just allocating a fixed-sized buffer that we want to use. So this is the Caesar cipher. Of course, it's a JS conference, so I like cats. So let's take and encrypt that. And once you encrypt it, this is the values you get down the bottom. And you can, of course, decrypt that as well. Now I'm going to show why the Caesar cipher is so weak. So we're going to go here and from the Gutenberg project, I've downloaded one of my favorite books, Robinson Crusoe. And you can see that it's just over 650,000 characters. What we're going to do is what's called a frequency analysis. And if you give this encrypted piece of text to a fourth grader, what they might notice immediately is there's a lot of characters that go again and again. That would be spaces. So that's really easy to see. And even though we shifted all the letters over, so the text is garbage, you can still see some letters are occurring more frequently than others. So if we formalize this and just count how many times do we have every single byte in the buffer, then we get a diagram like this. So here I've cheated a bit. The blue lines are the unencrypted text. The orange lines are the encrypted text. And you can see it's just all the bars have just been shifted over. If you count the shift, then you get the number 3. Another thing you could do if you didn't, of course you don't have the unencrypted text normally. One thing you can do is just take like a huge dictionary, take all the words in there, count the letters or the bytes, and then do the same kind of thing. And because of the law of large numbers, so if you have a lot of data, then this diagram should be pretty much the same. So okay, broken our first cipher. The whole science around cryptography and crypto analysis, so breaking ciphers, is what's called cryptology. So you can say that the Caesar cipher is essentially just security by obscurity, and we don't want that. So we can do better. We can actually do much better. We can do perfectly. So we're going to do the next cipher. And it's a perfect cipher. That means no matter how much computer power, even if you have a computer the size of the universe, even if you're God, you can't break this cipher. It's called the one-time pad. It's actually a really old cipher. It was invented in 1882, and it was rediscovered in 1917, and a guy took a patent out on it then. It has a couple of issues. The keys that you use to encrypt your stuff has to be just as long as what you're encrypting. So that's a bit of a bummer. If you have, you want to encrypt Robinson Crusoe, you have a 600 kilobyte file, you need a key that's 600 kilobytes. And how are you going to give 600 kilobyte keys to people? So it's not very usable. You do use it in very rare occasions, but it has a nice property that you can't break it whatsoever. And so here's an example of how to use the cipher. Up the top, we have one key. Then we, let's just skip ahead, and then we have the plain text. I actually like dogs instead, but that's not very popular here at the JS conference, so let's encrypt that. And the nice thing about the one-time pad is that you can make the text become whatever you want. So just below key B, that's someone who thinks they stole our key, but they actually got the wrong key. And if you take and decrypt with the key B, they won't know that they had the wrong key. It'll just decrypt, and also I like cats. So that way I have plausible deniability. Yeah. So, keys are problematic because you have to share them. And how do you share keys? You need a secure channel. You need some way to tell someone securely without anybody else knowing what was the key for this ciphertext. And the only secure way I can think of that you can share these kind of keys is like a dark back alley. But you don't know if an adversary might show up and like steal your keys or, I don't know, break your kneecaps or something like that. So yeah, this problem is called bootstrapping trust. How do you get to a point where you can actually start trusting other keys? Because once you have a secure channel, you can just start exchanging keys for other messages on that secure channel. But the whole issue is just like, how do we get started? So yeah, and you can't trust people on the internet because the internet is an insecure channel. But that's really not a problem because we're not too concerned about encrypting messages. We just want them signed so they're tamper-proof. Like, could we just like put an enforceable signature on our message so nobody could change the message without us knowing about it? Turns out we can. So we can use hash functions. Who here has ever built a user system to take in passwords? Okay, I actually expected pretty much everyone to have worked with like passwords before. Because when you put passwords into a database, you usually take the password and you use something called a hash function on it. In this particular case, we are going to use something called cryptographic hash functions. And hash functions are magic. I mean, you need a PhD in mathematics to just understand how they work on a basic level, so I have no idea. But here's a way to think about it. And hash function is a function that takes like an arbitrary large file, so it could be like several petabytes of data, and it compresses it into like a tiny, tiny, tiny fingerprint. So it's pretty much like a fingerprinting function. You also call it a digest function. So yeah, very, very large binary things we call blobs. So you can take like a blob of whatever size, and you can hash it down, and it'll always be the same size. And the nice thing about hash functions is that it's deterministic. So every single time you hash something, you'll always get the same fingerprint. So this is how you do hashes in Node. You import the crypto module. Here we use a hash function called SHA-256. That's a secure hash function still. So you can go use that at home. You update the hash function with whatever data you get in, and in the end you call digest, and you get out your fingerprint. So yeah, what is this good for? First of all, hash functions have a couple of properties that make them usable to us. They are deterministic, so whatever data you give them is always going to be the same fingerprint. They take infinitely large, or like extremely large data, and they make like a tiny little fingerprint out of it. They are what's called one-way, so if you have a fingerprint, you can never figure out what data gave you that fingerprint without trying out all possible data in the universe kind of thing. And that's also what goes with collision resistant, like two pieces of data should never give the same fingerprint, because a fingerprint should be unique, right? So this is all like very theoretic and like hard to get a grasp on, but so what can we use it for in the real world? Well, on the internet, you can use it for e-tags. So e-tags are a way of identifying your data. It has to be unique, so a fingerprint is nice, right? Another thing you can use it for is what's called content addressable storage. And I'm pretty sure all of you use content addressable storage on a daily basis. I don't know if you heard about Git, but Git is a content addressable storage mechanism. Every time you commit something to Git, you get out a little hash, and that's because whatever you put into Git will take that, hash it, and then fingerprint it. A hash is also a commitment. What that means is that you could take like a solution to some puzzle or something, hash it, and give the hash to everyone, and they'll know that you solved the puzzle. And then at a later time, you could reveal your solution, and they could verify that you actually used the same solution previously. Password verification uses it all the time there. In cryptocurrencies, you use it for proof of work. And you also use it for blockchains, but I hate the word blockchains because it's getting bloated, like big data got bloated. So the actual scientific word for a blockchain is a Merkle DAG. And you can also use it for file integrity. So file integrity means that you save the hash for a file, and then later when you go to read it again, you can just hash it and make sure that nobody has tampered with it. And that's exactly what we want to do. So there's a couple of hash functions out there. This was the first hash function I ever learned about. It's called MD5, But MD5 has been broken since I was like a toddler, so don't go use MD5. Okay, what's the next thing we have? There's a hash function called SHA-0, oddly broken as well. Stay away from that. Then we have SHA-1, and SHA-1 is actually the hash function that's used in Git. However, stay away from SHA-1 because there are theoretical attacks. It might be broken in the next 10, 20 years. So that's why it's okay for Git, because it's not really like 10, 20 years they have time to fix it, and it's not really that high value to break a hash in Git. But you might have seen all this trouble that's been going on recently with SSL certificates getting out of hand, and like some of the certificate authorities have been getting threats from Mozilla and Google, and actually one of them, the Chinese one, is going to be banned next year. So don't go and use SHA-1. What you can use is the next family of SHA functions, SHA-2, where you have SHA-256 and SHA-512. Those are both the functions that are exposed in Node.js. And you can also use the one I use, which is called Blake2. And we'll see how to use Blake2 in just a minute. And I'll cue a joke. So some people might be superstitious and go out and get a number plate. So yeah, don't run into this guy. And I actually checked in Victoria, both MD5 and SHA-0 are available as number plates, while SHA-256 and 512 are not available. So some people out there are superstitious. Just a little side note, once we're talking about hash function, is that if you go and encrypt passwords, don't use any of the hash functions I just talked about, because they're very easy to parallelize and not very good for passwords. There are specific functions out there designed just for doing password hashing. The most recent winner of the password hashing function was the Argon2 function. Scrypt has bindings in JavaScript as well. PBKDF2 is built into the Node crypto module. Okay. I was going to talk about how to do blockchains. I think it might take a bit too much time, so I'll just skip over that. So the problem with hashes is that anyone can compute the hash. You don't know where the hash came from. So if you have a source inside of Syria, and you want to make sure that whatever they're saying is actually from the same person that you thought it was, it's reliable, it doesn't really work to just take the continent hash, because if someone shoots down his carrier pigeon and reads what's on the SD card, and he doesn't like what's on there, he just changes it, hashes it again, and you have the integrity still preserved of the file, but now it was someone else who modified whatever you're trying to get out of the zone. So we have to do real-world cryptography. And you have a choice here. The crypto bindings in Node bind to something called OpenSSL. You might have heard that OpenSSL has had a couple of issues in the past years, because the code there's been a lot of bit rot, and the C code that's in there is pretty hard to follow, so that's why a lot of bugs can sneak in. But we have an alternative. You can use something called NAGL, which stands for Networking and Cryptography Library, which is all very clean implementations of very modern crypto functions, like the Blake2 function I was talking about before. And you can use libsodium, which is my favorite, which is a derivative of NAGL. This is how you would go. This is the module you go and install if you wanted to use Sodium. It was written by one of my friends, Matthias, and it was released just 2 days ago, so it's very new. So, how am I going for time here? If we want to make sure that the content that was sent out of wherever was actually from the person that we thought it was from, we can use something called asymmetric cryptography. Asymmetric cryptography is where you have a public key and a private key. So you're using asymmetric cryptography all the time. SSL is based on it. When you do Git, you also give your public key to GitHub so they can know that you are actually the one sending all the file content to GitHub once you do a Git push. Sometimes you also call the public key the identity, because now your name is your public key, and you call the private key the secret key too, because you're never going to reveal that. So if you have someone's public key, then you can send them messages. You can just take the message, encrypt it with the public key, and you need to have the private key to decrypt it. So that's really nice, in the way that you'll know that you can just get, like, public keys, that should be public anyway, so you can just get public keys from all your friends and use that to send them secret messages. You can also do another thing, which is very counterintuitive. You can take your own private key, encrypt the message, and send it out to the world, and then everyone who has your public key can decrypt it. But that doesn't really make a lot of sense, because then, like, what's the point of encrypting something if everyone can decrypt it? Well, yeah, like exactly. What you can use it for is signatures, and these signatures work just like in the real world. You take your file, you hash it down, you encrypt it with your private key, and then everyone who has your public key, they know that you own that public key, and they can decrypt it and see that this was actually a hash that you encrypted, because only you has the private key. This is in cryptography lingo called non-repudiation, because there's no way to dispute that you were the one actually encrypting that file. So how does the signature work? Well, first you need a key pair, like a public and private key. So you do that like this. Then you have your data, and you hash the data, and then you encrypt it with your private key. Yeah, I'll just skip over this. This is a quick introduction to how to do it with emoji. So I'll just skip over this. Okay, yeah, now we have tamper-proof publishing. This is all it took. It's all about cryptographic signatures. There's still quite a number of issues with HyperJournal, and that's why I didn't want to publish or release it today, because this is very sensitive software, so I want to be very sure that what I'm doing is right, and that the algorithms I'm actually using them in the right way. But I have a number of open problems, like delivering content to readers. So today I've only talked about how to take content out of a war zone maybe, and making sure that the person who wrote it is actually who you thought wrote it. But what if you're a reader inside an area where you can't just access the public internet? Then you might want to have an app or a website that can verify the content. Because if anyone is in the middle swapping out all the content for content they like propaganda, then you want to make sure, or you want to be able to tell that it was actually swapped out in the middle. Secure communication, so like one thing is to just sign your data, but it's not encrypted. So, I mean, anyone could read it, and in the actual real world, whatever you're saying might be sensitive. So actual encryption is something I want to build in there too. Another problem, a couple of problems that you have if you're saying something that other people don't like is that they might try to send you a denial of service attack, and that's becoming a very real threat now. Google has a project called Project Shield, which is actually aimed at helping journalists who are affected by DDoS attacks. There might be fake SSL certificates, so that means that we can't really rely on HTTPS, or well, we can, but if you are up against a government adversary, then they might just go to the certificate authority, the guy who makes all this SSL certificates, and say, hey, give us the keys. Another thing is DNS poisoning, which is something they've experienced in Syria, because it is the guy you're fighting who's controlling the communication medium you're using. And then we have the really, really bad guys. And the really, really bad guys, it doesn't matter how good your crypto is, because they might still be able to break your kneecaps, kind of thing. And that's also illustrated in this XKCD comic. So, yeah, it doesn't matter if, like, they're not just going to go and say, well, we can't break the crypto, so we're just not going to bother. They'll just go and get you and, yeah, do bad things to you. So, I'm not the only one working in this space. There's a lot of projects out there working on exactly this stuff. The blockchain stuff, if you want to look at that, it's called the Merkle DEX. There's a couple of projects that do that. Secure Scuttlebutt is something that's extremely interesting. It's a federated, totally distributed peer-to-peer social network that uses all these cryptographic primitives to make sure that only you can write to your friends and all that. Then you have, of course, the BitTorrent stuff. You have WebTorrent, and you have Matt McKeck, who's going to play tonight. He's made Ferment, which is an excellent tool. It's like a SoundCloud clone, but without anyone owning it. There's also the excellent DAT project, which my friend Matthias is working on, and a couple of other friends, which is for sharing scientific data using all this cryptography and peer-to-peer technology. So that's what I had to say. Thank you.
All right. Thanks so much for that, Emil. I'm super proud to introduce our next speaker from right here in Australia, Jacob Bass, who's joining us from Sydney. Now, even though he has a background in electrical engineering, he's now a full-stack web developer and, like myself, a JavaScript fatigue aficionado. One of the many costs of writing so much JavaScript is how we modularize it without dramatically increasing the development burden. So this is a topic that's very near and dear to my heart, which means I'm definitely looking forward to hearing his thoughts on modularity and mono repositories. So please join me in welcoming Jacob Bass.
Hi JSConf, and there are a lot of us here today. I'm a little bit nervous today, not to speak in front of you, but for two other reasons. One is that there was a release this morning of the project that I'm working on at 1 a.m., and I've just turned off Slack, so... And the other is that my boss is in the audience. Jed, raise your hand. Jed doesn't know this yet, but this is actually going to be a pitch for how we should develop our next project. I'd like a little bit of help from everyone towards the end. If I've convinced enough of you that this does seem like a viable way to develop a project, after the talk, could you just go up to Jed and let him know? So I'm going to talk today about modularity and mono repositories. And essentially what I'm going to cover is not whether you should use a mono repository or not, but the ways in which these techniques might be able to help you write better software. I did warn that I had a loud voice. Write better software or write more maintainable software over time. And I'm going to cover it in three phases. The first is I'm going to describe what a monolith looks like. Then I'm going to describe what a mono-purpose paradigm looks like. And then I'm going to describe what a mono repository can do for you. And if this is starting to sound like I'm covering off some unbelievable dream, we might get to that point at the end of it. So to begin with, I want to start from the perspective that good architecture is going to cost your company and is going to cost you less over time than bad architecture will. My fiancée, who promises me that she's tuning in to this talk now, is a bricks and mortar architect. And that means she doesn't have the benefit towards the end of a project of being able to go back over the things that they've been working on and fix up anything that doesn't work, like what's on the screen. As software developers, we have that power at any point in the project, time and money constraints providing, to go back over and change anything with very little cost. We should be making sure at the beginning of a project that the decisions we make protect us to make good decisions later on. Not necessarily to get everything right at the beginning, but just to be able to make the right decisions as we move through the project. There's a very famous quote by a chap called Melvin Conway that covers off the way in which you produce solutions compared to the way your organization communicates. If you have one person driving the entire company, you probably have one person or very few people driving the software solutioning as well, and this tends to show up in the way that you produce software. I think this is a very interesting idea, though, for the opposite reason, which is that the way that you produce software can actually change the way your company communicates. If you tend to produce monolithic software, or if you tend to produce very isolated software, you'll also probably have isolated teams, and that means the information inside your company's systems are going to be very isolated. This will lead to things like very small bus factors and dangers when people leave your organization, as well as needing to rely on very small numbers of people to be able to fix any problems that come up. So what does your organization look like? I'm going to cover a little bit about what mine looks like. Like I mentioned, at the moment I work at ThinkMill, and we're a developer consultancy. And what that tends to mean is that we work on a number of different projects at a time, and they're all relatively isolated because different clients means different code bases, and we have individual teams running them. And so a lot of the information is kind of constrained into the system that we're looking at the time. We do the obvious things that NPM gives you to break out that information, as I'm sure everyone does, but it does mean that reusing software in between projects can be a little bit challenging. So let's start with the project that I'm on at the moment. The project that I'm on at the moment is basically just a monolith. And this is not a bad thing. I definitely don't characterize it as a problem. It's often the fastest way to get a solution to market. but it does come with its own set of challenges. The first is that keeping an entire monolith in your head can be pretty challenging. This is a relatively small monolith. It only has about 30,000 lines of code, pure JavaScript code, but 30,000 lines of JavaScript code. So this can be very challenging when you need to make a change, especially if your architecture patterns have evolved quickly over time. Knowing where files are, knowing where functionality is can be very difficult. Similarly, we work on a lot of open source projects. And this can mean that we end up with a smaller subset of small projects and functionality. And we'll see that we break that up into smaller pieces. So we have the individual projects that make up the Keystone project, the large open source project that we maintain. And those break up into smaller pieces, are easily shareable and easily reusable. But shipping these kind of features throughout a system can take a lot of effort and a lot of time. So finally, the thing that I'm here to try and sell Jed specifically on and everyone in general on is a monorepository. That idea that it will bring some kind of value to the business in general is what I'm going to try to focus on. So let's take this mono, and we're going to cover off 3 different ways that a monorepository might be able to help your organization deploy, release, and develop software over time. The first one we're going to focus on is deploying a release. So if we look at the way that a monolithic software structure deploys a release, you just deploy the release. You have a single deploy candidate. There's one piece of software inside your application that goes live, so you deploy it. I'm actually just going to interrupt myself quickly here. Terrible looking slide, and if I'd only asked Sharky for help earlier with the CSS for this demonstration, this would have gone a lot better. So I apologize. So a monolithic structure has a single deploy candidate, and that's what we deploy with. In contrast to that, a monopurpose repository, a monopurpose paradigm rather, is a number of repositories who have a single deploy candidate. In the JavaScript ecosystem, the people who do this the most are people like James Halliday or Sindra Soros, who tend to produce one small package for exactly the feature that they're working on, no matter how related that might be to another package they already have. And this is an example of things like the Unix ecosystem, where you have tools that are meant to do one thing and just do that one thing well. But what you end up with are patterns and projects that are all kind of related, but all very distributed. Whether you remember that you have this project in a different place, whether your documentation and your discovery mechanisms are good enough for your team to remember that these projects exist, these are the challenges that come with a monopurpose organization. And so what we end up with are innovative tools like style guides or individual internal component repositories, or using GitHub descriptions to make discovering these new mechanisms more obvious. Whether we succeed in doing that or not is often down to whether our organization has discovery as a priority inside the organization. Finally, we have a monorepository. And again, although a monorepository is the encapsulation of a number of projects inside one repository, to deploy something like that really should only ever be a line of code. What we end up having is scripting the individual deploys inside the repository, but then kicking them all off in one command. The advantages here are that while you do have this disparate, separate set of steps that occur, you, the developer, only have to do one thing. And that is much less risky than if you have to manually type in 20 or 30 commands. I know that personally I have forgotten to deploy a key piece of infrastructure because I was deploying 15 other pieces of infrastructure and found that out late at night when a deploy didn't work the way that it was meant to. And from that point forward, I've made sure that I try and keep as few moving pieces as part of a deploy process as possible, which is where my interest in this area kind of stems from. Let's take a look at the idea of sharing common functionality. If I ask how many people in the crowd have heard of the DRY principle, don't repeat yourself, basically everyone. This is good. We're JavaScript developers on the most part, and JavaScript gives us such a simple mechanism to extract and share code. We'd be wasting potential if we didn't take advantage of that. But not every project does that out of the box. So if you look at a monolithic structure, by definition, a monolithic structure will not share code out of the box, because that's what a monolith is. It's all of your code encapsulated in a single repository. As soon as you start to move to more of a modular strategy, You have the ability to break out as small a function as you like, and even make the entire JavaScript ecosystem dependent on that one small function, as we all found out a couple of months ago. Similarly, with a monorepository, you have the ability to have that same small function take the forefront of your application, take all of the functionality just related to that one module, extract it and deploy it as an individual NPM module, but still retain the ability to edit it inside the larger context of your project. And what that gives you is the ability to see the context of your entire application, how it relates to that single module. It's a very powerful paradigm. The final thing that I'm going to discuss in the context of these three repository patterns is the idea of making atomic changes to shared dependencies. So what we're going to look at with this one is when I have to make a change to something in my ecosystem, how do I roll that change out through all of my projects? In the case of a monolith, again, you have a single deploy. You have no way to roll out changes to a distributed ecosystem because your code is just related to your single deploy candidate. You might have a couple of steps that deploy multiple monoliths at a time, but you have no way to encapsulate that inside one monolithic structure. For a mono-purpose paradigm, where you have lots of NPM modules individually, again, there's no real way to encapsulate that information inside one repository, unless that one repository's only responsibility is deploying all of your other repositories. And at that point, you're back to having, again, how do I keep that one up to date? How do I know that that refers to everything that is there? Finally, we have a monorepository. And because you have the majority of your code inside this one structure, making a deploy or making a release is as much as adding the files, committing them atomically, creating a pull request, having the pull request reviewed, merging it, and you're finished. At that point, if you have automatic CI integration and CD integration, you can deploy your code automatically. If you don't, then you have your scripts that you run manually at the tail end of a release, and you run those. But you can see a snapshot in time at every step that you change something in your application, and you can follow those snapshots back through history and see, this is the point that we made the header green because we thought it would give us 25% more revenue. These snapshots of history will give you the ability to see throughout time the changes, not just to the individual modules and try and make them match up, but to your entire ecosystem, your entire company or organization's projects. All of their history is encapsulated and shared in the same place. So in comparison, we can see that a monolithic structure is very strong at deploying its individual release candidate. But it's a little bit less able to share that functionality across an ecosystem, and it doesn't have the ability to know about the larger context that it runs in. Similarly, a monopurpose or a modular structure does not have the ability to know about its larger ecosystem. And while it shares functionality very well, deploying those individual bits of functionality can be a little bit challenging. Finally, if we look at a monorepository, what we end up with is the ability to deploy these changes atomically, to share functionality across our entire system, and to make atomic changes throughout that system as we go. So this is the paradigm that I'm going to describe. Finally, we have this concept of a monorepository. And what does that mean, and what does that look like? So that's what I'm going to demonstrate now. And depending on how I run for time, I might also live demonstrate it. We'll see what happens. So a brief note before I begin getting into what the code actually looks like. This is not a talk on Learner. Anyone who has heard of Learner or used Learner in the audience, this is not that talk. Learner is a tool for managing monorepositories, but I'm not going to delve too deeply into how it does it. There are a number of options in this space, Learner just being one of them. And if anyone is interested in that idea after this talk, I definitely encourage you to have a look at these three options and to see which one makes sense. Learner, Formidable Labs' builder is another one. Formidable Labs, the open source division run by, I think, Ken Wheeler. And finally, there's a pattern called the, I think, ALA pattern. And the idea here is that the way that Node's module resolution algorithm works, you can actually just store all of your source code inside a folder called Node Modules, and it will resolve up and down the Node Modules tree and find everything that you need. It's quite a cool trick. And if you look at the PouchDB repository, that has this implementation running at the moment. So you're definitely free to do it yourself, but your mileage might vary. And the amount of code that you end up writing that rebuilds existing functionality somewhere else is definitely a risk. And at the same time, breaking out of something like Learner to a different pattern is not a big deal. It's very easy to move from one of these to the other. So let's look at what the setup for a monorepository looks like. We're going to cover off starting a brand new project. We've got our first day working at the new startup, and we have to create an entirely new repository and an entirely new structure. So we run learner init. And what learner init does is initialize a repository, initialize a Git repository, create some files, and create a packages folder. This is the end result of creating your first monorepository. I've created 2 folders inside this repository, a demo button and a demo header. The naming of these folders just corresponds to the name of the package JSON inside the monorepository. And that's what this looks like. So you can see here that I've scoped the package JSON to an organization name. That's freely available. And I've also declared inside my header that I rely on my button component. When I start working on this, immediately I'll be able to make changes to either of them and see those changes reflected where they're used. So once I've declared my first few projects, I run learner bootstrap, and it symlinks together all of the dependencies. What it actually does under the hood is build a great dependency map of all the different things that rely on all the other different things. It will install anything that you don't have inside your monorepository, and it will symlink everything that you do. So what that means is that rather than installing from npm some candidate, or instead of running npm link manually yourself to set up these links, instead learner just takes care of all of that for you. Finally, that's what we have here. So we see we have the same 2 folders, but we see that inside the header component, we have a direct symlink to the button component. At this point, any changes that I make to the button component folder will be reflected in what the header component sees when it requires the button. So this is all kind of architecture-y and DevOps-y. Let's look at some actual JavaScript code. Well, not yet. Because it's JavaScript, we now install Babel and Babel ES 2015 and Babel React, and we run ESLint, and we install Mocker, and we install React. The same kind of stuff that we would do for the beginning of every project. But because we're doing this inside a monorepository context, our dev dependencies can be shared across our entire application. So what that means is you only install these things once at the top level of the monorepository, and you can reuse them everywhere inside the application. So this is quite good because has anyone gone and gotten a coffee while waiting for an npm install to resolve? Yeah, right? So with this practice, you run npm install once, you have all of your dev dependencies waiting there for you, and to start a new project, you just put the actual source code down. You don't have to set up anything other than what you already have. So what we end up with now inside each of our components is a Babel RC in case they have anything particularly peculiar about how they need to render JavaScript code. And we have the exact same learner structure, the exact same monorepository structure. So if we look inside a component, in this circumstance, they're just ordinary React components, but this is not a React paradigm. This works for all ordinary JavaScript code. But what we have at the top there is a ES6 modular import. Import button from organization scope / package name. We're not walking relative paths. We're not like going, cool, on the file system, if I'm in development mode, find the file here, otherwise use the actual file from npm. We're not doing anything different than what we actually do in production. Instead, what we have is just a call to a button component. And because we're symlinked inside node modules, it knows exactly where and how to find that component. And as we make changes to the button component, they'll automatically show up here. I'm not going to go too deep into the content on this slide. The reason why I have that in the presentation is just to highlight that everything that you can do normally inside an npm component, you can do as part of a monorepository. Linting, testing, compilation, watching, hot reloading, all of that works very simply. You just essentially bring it up one context to run from the root of your project. And with learner specifically, or with bash generically, scoping those commands to a particular project is achievable. So it gives you the opportunity, depending on how comfortable you are with shell scripting, to either take this into your own hands or to use an existing project that's already solved these problems. So a big part of what I care about is developers. And the developer experience is something that I've spent a lot of time working on and working with and trying to figure out the right, nice patterns to make developing software enjoyable. And what I'm going to show on the screen here is a project called Storybook by Kadira. Essentially what Storybook is an encapsulation of a living style guide for your application. All of those components that are sitting inside my packages folder as separate npm modules are required by the Storybook application, and I can use that to render them with props in the specific ways that they're used. Now, ordinarily, this works really well inside a monolithic structure where all of your components are just files inside the same tree. But if you envisage having a modular structure where all of your files are in separate parts of your file system, having a project that integrates all of these things together is now another module that you have to maintain. You have another area of source code with another project that requires these files and another project that has to make sure that they're all at the same version or at the right version. Instead, with this system, inside a monorepository, at the root of the application, it just walks the tree and finds all of the places that a story is declared and imports it. So when you add a new project into the monorepository, you add a new story, it's automatically picked up by Storybook, and it shows up in the browser when you load the story application. What you can see on the screen, what's probably played a couple of times now, is hot reloading of the changes that you make across the module. Those occur not only across the module that you're looking at if I make a change to the button component, but as we'll see in a slide or two, that they also occur for anything that depends on that button, which means you see in real-time changes, not just to the ecosystem that you're mutating, but to anything that uses that module inside your entire application. Rather than having the concept of work on a module, publish it, integrate it into something, see if you broke anything, come back, try it again, publish it, or deprecate it, or whatever you're going to do. And instead of having to manually go around with an NPM module fix or an NPM link strategy to try and get things to integrate nicely together, instead what we end up with is a way to automatically see these changes propagate throughout our system. So this is quite a nice paradigm. It's quite a nice way to make these changes to our software. So let's think about making a change then. So we come in the morning, and the product owner has said, we love the button, we love it a lot, big fans of the button. But it's just a default button. We'd like to give it some styling, we'd like it to look individual. Can we change the button? Okay? So we come into our component, we come into our text editor, and we add the styles, and we see the change automatically reflected in the button. But we also see the change automatically reflected wherever the button is used. So we have here a header component that also uses the button component. These are separate NPM modules. And when you make the change to the source code for the button, it automatically is picked up and reflected in the source code for the NPM module. And vice versa, as you take the change away, the new NPM module, the header NPM module is reflective of that change. So far I've just shown front-end integration of this. Is this only for front-end JavaScript, or is this only useful for integrating front-end components? Of course, the answer is no. Because it's just ordinary JavaScript, and it's just taking advantage of the ordinary way that JavaScript requires work, using this with a back-end functionality is the same process. So here we have a simple Express server. Well, simple, it's using Webpack and Webpack middleware and a bunch of other plugins to make it work, so simple. But what we end up with is the ability to create a front-end component that is just specific to this server, in this case, a landing page for our startup application. But that landing page consumes the modules that we have elsewhere in the ecosystem. So when we make a change, and we can see here, again, the storybook showing us all the different states that we might be in with our components. When we make a change to that component, we can see it reflected in the actual server code, and it picks it up in real time as well. So whenever you make a change to any of your individual components, not only can you see them live reflected in the actual component render, you can see them in the integration renders, and you can also see them in the full page renders of your servers that are part of the monorepository. You have full end-to-end integration of all of your components throughout your system. And that's reflected here is the deploy strategy. I'm not going to go too deeply into this because it's very individual to learner, but the idea is that you can deploy these things at independent versions because your NPM version is held separate from your repository state. So if you have a minor patch for one component and a major bump for another component, you can do that separately inside the same Git repository and push them out as part of the same commit. It's still atomic, but you just have that separation of versioning separate from the fact that they happen to be used together at that step. So this probably doesn't look very different from how people are working now. And that's a good thing. Basically, the benefit here is not that this will revolutionize or make a radical change to the way that you develop software now. Instead, the idea here is that with these practices, you're able to introduce small developer experience tweaks that will make your life a little bit easier. Whether you take away from this that having things integrated together end to end at the time that you're developing is a benefit, or whether it's that being able to deploy releases atomically is a benefit, all of these things are small wins that we can make to make our lives as developers easier. The other part to take away from this is that it doesn't require a massive change. It's something that you can integrate into your organization gradually, and you don't have to buy entirely in one go. So there are two paths that you can approach this from. There's the path where you come at it from an existing monolithic structure, where you can say, cool, all of my code is in one repository, but it's all in one NPM module or one server. How do I break it out? And from that point of view, all that you have to do with that is take the code that you have inside your monolithic structure, extract out just a part of it that is going to make sense as an NPM module, and put both your monolithic structure and that NPM module inside one monorepository, and then keep developing your monolithic structure as you normally would. And then the next time that you come across a small change that would make sense as an NPM module, extract it out of the monolith into a small NPM component, bring that out into your monolithic, into your monorepository structure, and you kind of continue down that vein, slowly making small changes. The opposite approach works as well. If you're coming at this from a large distributed system, like a large distributed set of front-end components, all you really have to do is pick one as the starting point for your monorepository, put it as the only package in your monorepository, and start developing against it. When you next come to making a change to something, bring that into the monorepository as well. So you can gradually apply these patterns as you go. And breaking out of these patterns is also relatively straightforward. What you have to do to break out of the pattern is to take the modules that are inside the monorepository into their own folder, initialize them as Git repositories, and you can continue deploying them to the same NPM target that you were before. So everything is great now. Well, not necessarily. There are a couple of caveats that I want to cover. The first is that your Git checkouts will definitely slow down. If you visualize having one project's worth of Git, having n projects worth of Git is going to be n times as much Git, simple mathematics. And what that'll mean is that your Git checkouts, your Git clones, and your Git pushes will slow down, especially as all of the developers in your company will be integrating into the same environment. This is not all that dissimilar from having all of your code in separate environments and then having to pull down each of them, and I haven't seen it as a scale. Then that might be a concern that you have to field. You need to get a releasing process using Git tags. Can't just be the exact version number. You're going to have to either version it at the module versions and have a couple of tags pointing to that. There are other ways that you can get around this, and there are other processes you can use, but you're probably not going to be able to use the exact same Git tagging process you had before. And finally, build tooling. I covered a couple of ways to approach build tooling, but you are going to have to think about it. JavaScript over the last 2 years has made us all have to think about build tooling in some capacity, even if it's just applying Babel or Browserify or Webpack or something like that. This process will also need you to come up with a way to run your build tooling in a certain way. But the advantage here is that once you've solved that once, you can just use it again, not copying and pasting it, not turning it into an NPM module, without needing to replicate it and to update that build tooling in place. You don't have to make that change throughout your ecosystem. So I'm going to touch off on one way to approach a middle ground for this, and that's the Zelda project by Feros. This project is a way to take all of your NPM modules that are separate, clone them together, and link them together in the same way that Learner or other monorepository builders do, but it won't store them inside the same Git repository. You retain your individual Git repositories, but you can make all the changes in the same way that I was showing before. You don't have the benefit of storing this in source control, and you don't have the benefit of sharing it across your team, but it is a way for you to get used to how the development process works with these tools and see if you are willing to make the buy-in towards changing your process over to this kind of way of doing things. Trees are a way to kind of take the best of both worlds between modular systems and monolithic systems. They do come with their caveats, but I believe that they will lead to better developer experiences and to a stronger culture of reuse over time in a project rather than rewriting it. And that's that. Thank you very much.
Thank you, Jacob. All right, so we're going to head out to lunch now. We have a little over an hour. The catering will be where the registration desk was. Please queue outside up the driveway, not in the venue. It's sunny outside. There's a small garden out back through the back kitchen. It's small, so don't all rush there. But enjoy the next hour, and we'll see you here at 2.
Hello everyone. Next block, best block.
Hello. Hello, JS Conf AU. Has everyone returned from the garden? I know it's tempting to stay outside, but you're really missing out if you're not coming back inside now. So, how was lunch? Yeah, did you enjoy it? Yeah, some applause for the caterers. It's so tasty. Really good food. Our next speaker comes all the way from Portland, Oregon today to join us here. And Jessica Lord is a urban designer become open web developer. Most recently, she worked at GitHub. At GitHub, she has contributed to github.com, to the Atom editor, which I'm sure most of us know and maybe use. But most notably, she started and built up the team that's working on Electron. Yes.
Whoa!
Yep, I agree. To quote Anil Dash, Electron is one of the most undersung successes in software development, and I couldn't agree more. I'm actually really excited because I recently started to work on my first Electron app, and it recreated a little bit the excitement that I had when I first started to build stuff for the internet. It's generally amazing and empowering to build something for desktop, and if you haven't tried it, do it. And Jessica's resources that she put out there about Electron have saved my commit messages many times. And so really, listen to her. She's the #1 resource for all things Electron. So please, a very warm welcome to Jessica Lord.
Woo! Okay. So people have heard of Electron? Okay, no, that's awesome. I don't know. This is very far away. I come from the Melbourne of America, Portland, Oregon. I don't even need to do this slide now, which is great because my talk is too long. So I have talked about Electron in many ways before. Like I had to talk about it internally at GitHub to be like, this should be a team. We should work on this. And I've talked about, what it is, why it matters that it does what it does, and then there's talking about designing with Electron, which is a whole thing on its own, and then developing on Electron. And a lot of this has been geared towards speaking to people coming from node development backgrounds and people coming from front-end web development backgrounds, and so that's sort of the space I'm into, and so I know how to talk to them, and I would talk in that way. And I hadn't thought for a while about people who aren't coming from Node, people who aren't coming from web backgrounds. And so a few months ago, there were some other GitHubbers that were starting to work on Electron, and I'd done all this, Electron is the best, you should do Electron, it's so fun, it's so easy, you should do it. And they were running into problems, and I was like, whoa, how is that possible? What? And then I was like, have you built web pages before? And they were like, no. And have you worked with Node before? No, definitely not. And I was like, oh, I don't think there's anything out there for you. And that felt crappy. And I felt like everybody deserves documentation. And so that spurred me on sort of a personal challenge to do this site, which is Essential Electron, which was a challenge, or I made the challenge for myself to try and distill Electron into the fewest amount of words as possible, and then especially the fewest uses of jargon. And if there were words I couldn't avoid using, like JavaScript, I wanted to define those things in simple terms and provide links to learn more about that. So I just wanted to say, maybe this is something that we should think about for other kinds of projects. It really was a good personal challenge to force myself to step out of my bubble and the things that I assume that people know, because these other people at GitHub, they were also engineers, they just hadn't come from a web and node background. And so everyone in this room has a different background and different experiences too. So if this talk is total crap to you, you might want to go to Essential Electron, and I hope that it can be helpful. But all right, so this talk It's not about designing Electron, and it's not necessarily about like 1, 2, 3, get your Electron app started. It's more about how Electron electrons, because the more I've been involved with Electron, the more I've gotten excited about learning how actually Electron makes the development experience it does possible, because developing with Electron can be fun, and it can be easy, and there's all this stuff under the hood that's enabling that. And so that's what this talk is about. But first, we can start at the beginning. Electron is an open source framework for building desktop apps with web technology. And when I say desktop apps, I mean applications that work on Mac, Windows, and Linux, and also ARM. And with web technology, I'm talking about HTML, CSS, and JavaScript. And you might already be, well, we already know everyone. Lots of people know about Electron, so that's great. You are probably using Electron apps. Maybe you're using Atom, which is the text editor from GitHub, the very first thing built on Electron. And Slack is on Electron, the Brave browser, Visual Studio Code from Microsoft is another text editor, WordPress, WhatsApp. There's a ton of cool stuff happening on Electron, and then there are over 220 apps listed on the website right now, from small startups to individual developers. Some of the projects mentioned in Emil's talk earlier have Electron apps also. So typically, native apps, like if you think about your mail app or your calendar app that came with your computer when you got it, were written in the native languages for that operating system. And if you were a project or a company and you wanted to build a desktop app, and you wanted it to work on multiple operating systems, that means building those teams that use those languages. A lot of times it means separate code base. And a lot of times it means maybe you actually just don't ship to all those platforms. But over the last few years, the browser has gotten really awesome, and JavaScript and the web languages started trying to combine parts of browsers to enable building desktop apps. And so Chromium Embedded Framework is one here, up there. And they've all done this in kind of different ways. There are a few more, but this is the group of technologies that Electron belongs in, technologies that are using all or part of apps with web languages. For Electron, Electron started because it was built for Atom, GitHub's text editor. And the Atom team, way back when, had tried a bunch of the existing things, but none of them were really as fast as they needed or had Node integrated in the way that they needed. And so GitHub contracted Cheng Zhao, who's amazing. He was actually working on NWJS at the time, and GitHub contracted and then later hired him, and he built out Electron for Atom. And it really was, for a long time, just a dependency of Atom. And when Atom became open sourced in 2014, everything got open source with it, so that included Electron. But it was called Atom Shell at the time, and it just kind of was hidden there in the org on GitHub, and there, it had no website, no one was talking about it, but slowly people were starting to figure out that actually it was a really powerful tool. And it was really Microsoft building Visual Studio Code, and they were going to launch it, that made us realize, like, those of us on the Atom team, that we needed it to have a name. It doesn't need to be named Atom Shell. And so the first step in Electron was it got its own name. Thank you, Microsoft, for building a text editor. And then that's when I started pushing to build Electron into its own team, moving it out of Atom and really putting a lot more resources into it. And so in May of 2016, this year, we launched the 1.0 of Electron. And so that was awesome, and there's a lot of work in that, and it was really good to get Electron to a stable place. And so Electron is maintained by a small team at GitHub, and by small, which I know is relative places, I mean like 4 people, and then many other contributors, because Electron is a unique project in that it's almost this accidental project that evolved and got really popular, and it's driven more by the community than any other project, really. And so a lot of what's going on in Electron is being influenced by the other companies and the other places that are building on Electron. And so, Slack is contributing a lot of stuff upstream, and it's a really It's a really cool project to be involved in for that reason. All right, so that's how Electron came to be, but what Electron is actually made of on the inside can be distilled into these 3 parts. Oh yeah, so even though Electron allows you to write desktop apps with HTML and CSS and JavaScript, Electron itself is mostly C++, and it's combining these 3 things. It's combining Chromium for web pages, Node for file systems and networks, and then it has a set of native APIs for desktop integrations. Chromium is the open source core of Google Chrome, and that's what Electron is using to build upon, but it's not using all of Google Chrome, which is something that is special about Electron. It's just using the part of Chromium that knows how to render web pages, and that makes Electron a little bit smaller, a little bit easier to update, and Electron has this really useful library called BrightRay that lets you build applications with Chrome, because I don't know if anyone here has tried to compile Chrome, but it's not something you want all of your users to have to do, and you don't want people to have to do when they're developing, and so Electron has made that a whole lot easier by not having to have you compile Chrome. And so because Electron is built on top of Chrome, you're getting the latest things that are shipping in Chrome, and Electron updates with stable releases of Chrome. And so when you're designing your Electron apps, you're designing for one browser, and you're using everything that is shipping in the latest Chrome. You can go to caniuse.com, and if you can use it in your Electron app, and it'll work across all the platforms. So CSS properties and Shadow DOM and all the things that are coming out, you can use. Of course, you get the DOM that you know and love, and then you also get dev tools. So if you come from a web development background and you're used to debugging and designing your page with dev tools, you can do the same thing when you're building your Electron app with dev tools. And then you get popular DevTools extensions. The word popular there is because not all DevTools extensions are there, but ones for like React and things like that are supported. And so if there is a framework that you like using, it probably has Electron DevTools support. All right, and then Electron has Node. All of Node is built into Electron. Electron's using it as a shared library. And you can use it seamlessly throughout your apps. And having Node means, of course, you get the full Node API. Everything that you can do in Node, you can do in your Electron app. You can use all the code that everyone else has written in the 300,000 plus NPM modules. And if there's something you can't do in JavaScript or you want to do in a low level, you can build or use existing native modules in your Electron app too. And then finally, Electron has a set of native APIs for integrating your app into the desktop, because Electron's it's not a shim around a web view. It's not just showing you a web page. The set of APIs is to really let you build a native app that works and integrates with the operating system like a native app. So doing things like opening windows, changing the style, creating protocols, it's really up to you to integrate as much or as little as you want. Okay, was anybody wondering about V8? Yes, okay. So both Chromium and Node use V8 as their JavaScript engine, and Electron's not using two V8s because in Electron, Chromium and Node are actually sharing one copy of V8. You can set Node to use a different V8 than it normally comes with, and that's what Electron does. And then Electron has Node use the V8 that's shipping with that Chrome. And so a lot of the times that just works. Chrome is moving faster on V8 than Node is, and so it's not always a matchup, and sometimes it means patching Node, but a lot of times not. But this is how in Electron they're just sharing one V8. And so because you're using the latest V8 in all of your Electron apps, you also get things like over 90% of ES6. So if you love fat arrows, go and live your best life and write fat arrows, and you don't need to precompile and do all of that stuff. You can probably just write it as it is. So to recap, you have Chrome for drawing the web pages, Node for file systems, and then they're sharing a single V8, which is Chrome's V8. And then you've got the native APIs. But we can take it further. This is the crazy part where I'm like, this is what I'm going to talk about at this talk. I hope people are excited about that. So I just found this exciting. Chrome and Node both have their own event loops, and there are different projects that have tried to do this in various different ways to make two event loops happen. Sometimes they try to make one use the other one's event loop, like forcing Chromium to use libuv, which is Node's event loop. Checking, is there a new event? Is there a new event? Is there a new event? And that burns up a lot of resources and can make an app really slow. And so this is a challenge, right, for building a framework that's going to combine Node and Chrome. And so what Electron does to figure this out is it creates a new thread, and this new thread lets Chromium's message loop know when there's a new event in libuv, and we're going to walk through it. So when Electron boots up, it's Chromium at the core, and so Chromium is starting with its message loop, and then it's loading up Node as a shared library, and Node is using libuv. But a newish thing in libuv is that there's an exposed file descriptor, and libuv is using this file descriptor to know when there are new events to process. But you can actually listen to that file descriptor yourself, and so Electron has a thread sitting in the middle that is also listening to the file descriptor in the same way that libuv does. And so when there's a new event, Electron's thread knows about it, and then it tells the Chromium message loop to stop, empty out the libuv pool, and then everything starts back from the beginning. And this is how Chrome is able to, Electron is able to make using Node really seamless, make things really fast. You don't have something else weighing down Electron apps. And so Electron, a lot of its speed really just comes down to how fast Chrome is, and luckily Google has a lot of people on that. But the important part of all of this is that you get Node. You get Node totally seamlessly and easily inside of Electron. Okay, so because Electron is built on top of Chromium, and Chromium has a multiprocess architecture, it has a multiprocess architecture so that all your tabs don't crash the other tabs. Electron inherits this multiprocess architecture. And this is the title track. There are two processes in Electron. It has the main process and the renderer process. And the renderer process controls the app's life cycle. It is the place where you start your app, where you quit your app, and it does all of the operating system intensive things like opening dialog windows and things like that. Things that you don't want to happen in another process where people are actually looking at your UI because you don't want to slow it down. And then the main process also creates all of the renderer processes. And then the renderer process is all of your windows in your Electron app. They're the browser windows. It's the part of Chrome that just knows how to draw a web page. And you can have multiple renderer processes. They can be invisible, and I'll talk in a little bit about why you would want an invisible thing. Each of them is a separate process. So just like the Chrome tabs, when one tab crashes, it won't crash the other. You have that kind of functionality in Electron too. In your main process is JavaScript files. It's just like writing Node, and of course you have all of Node. And then you're making use of the Electron APIs that are for the main process, and I will talk about that. And then in the renderer process, just like when you're building websites, your files are HTML files and JS files, well, CSS files too, man. And you've got all of Node, and you've got the DOM APIs, the dev tools, and then you've got all the Electron modules for the renderer process. And you can kind of think of these two processes like Chrome when you think, well, it's like, you can imagine it this way because this is how it actually is. That's why. So if you have Chrome open and you have no tabs open, no windows, but you've still got your menu bar at the top, that's like your main process. It's the place where you are quitting the app, and it's the place where you can click to open a new window. And then each of your new windows is a new renderer process. And then, of course, in Chrome, you can create multiple tabs, and each of those is its own new renderer process, and it's the main process creating these. But of course, you might not be making a browser in Electron. Some people are, but you might have like a menu bar app. And so you can think of the little icon at the top as your main process. That's what's controlling the life cycle of your app. And then the window that people actually see when they click on your menu bar app, that's your renderer process. If you have a more traditional desktop app that has main windows, big windows on the screen, again, your menu bar is like your main process, and then the windows that the users see are each of your renderer processes. So if you are making a mail app, you might have one big window that is for the inbox, but then open new smaller windows for people to compose messages in. And then you can create a hidden renderer process you just create a new browser window and set it to show hidden, and you can actually just farm off JavaScript to this. So places where you might normally use a web worker or something, you can just create a new invisible renderer process so that the JavaScript running in that is not affecting anything loading in the actual visual windows that you have people looking at and interacting with. And finally, you can also have the main process create a renderer process window. And then in that renderer process, you can use a web view, which allows you to have external content embedded in a renderer process that's in its own separate process. Did that make sense? This is what Slack does so that you can't type in crazy code and blow up computers. It is isolated, sandboxed into its own process within a renderer process. So the Electron API and these processes. The Electron API is grouped into modules, and each module is associated with a process. And it makes sense most of the time. So the APIs for creating new windows are called, or that module is called the browser window module. And like we said, the main process is creating new windows, creating those renderer processes. So that's a main process module. But some of them work in both. So for instance, the module for using the system clipboard to copy and paste, you can use that in both of the processes. In the documentation on the API page, there's a list beside each module telling you what process it belongs to. And once you're on the page for that module, you can also see that it's a renderer or a main process module. And so some of these modules are going to be core to like 99% of all Electron apps, right? Most people are going to create some window for users to see, so probably everyone's going to be using browser window. But everyone might not use the system preferences module, which will let you check to see what color theme on Windows people are using, or if on Mac their menu bar is dark or light. It's up to you, and this is, like I said, that you can really kind of go as far to integrating as you want. But another common module will be the IPC and IPC renderer modules, because these are the ways that you communicate between the processes. So we talked about how the main process creates the new renderer processes, but we haven't talked about how you can do anything between them, right? Because if the main process one is the one that can open up new dialogues and people are actually interacting with your window in the renderer process, how does the renderer process tell the main process, I need a dialogue window stat? And so that's what IPC modules are for. And so there's an IPC module for the main process and one for the renderer process. And so this is an example of how you would open a dialog window from the renderer process. And so in your script tag, in your HTML, you can use Node. And you would require Electron and the IPC renderer, so the IPC module for the renderer process. And then you would send a message, which you can name anything you want, but you give it a string, a channel name. And then you're listening for that in the main process. So when you make this happen in your renderer process, the main process is listening, and it knows because it's using the dialog module, which it can use because it's the main process. And then it runs the dialog show open error box. And so that's how you would trigger something happening that needed to happen in the main process. There's another module called remote that lets you use the main process from the renderer process. And in my head, get ready, it's like it's a box with rubber gloves, and then you can touch the things that are inside the box, but you're still not in the box. I couldn't think of anything else. And so it lets you have the feeling of being in the main process without actually being in the main process. So here's the same example as before, but using the dialogue, but using remote. So you can see it's almost the same as we would write if we were in the main process, but instead of requiring Electron .dialog, we do remote.dialog, and that tells Electron that we're using the dialog module remotely from the renderer process. But the thing to know about this, that it's a nice convenience method, but actually under the hood, it's using synchronous IPC calls. So if it's important to you to have things be asynchronous, you should probably just do it the manual way with IPC. And then, of course, if you're doing things with data between the renderer processes, like anything that is in the latest Chrome, all the things that work in HTML5, you can use local storage API, that kind of thing. You can also use IPC to create global variables in the main process. And because you've got Node, you can also just read and write files and save data that way, right? You can create an object, write it to a JSON file, and read it later. This is an app called the Electron API Demos app, and it is an Electron app that demos the Electron APIs. So I've only touched on some of the core modules, but there are a lot of modules, and this one goes into all of the common ones, the ones that you're most likely to use in your app. And it demos them so you can see what they are, and it also gives you sample code. And what's cool about this is because it's an Electron app, the sample code is the real code. We are just FS reading the file and then appending it to the DOM. So it's also cool in terms of maintainability for this app. So once you change the real code, the sample code is automatically updated as well. So it's available in the Mac App Store as well. All right, so Electron API and then the different operating systems. So we talked about the Electron API and the different processes, but most of the time, well, all right, back up. So the Electron API has a lot of modules that just work across all of the operating systems. So like the dialog example I was using for like opening up a error message or opening up an open file dialog, you saw that I didn't have to say like, if Mac this, if Windows do this, because all of those common APIs, Electron targets the operating system for you. So you just write dialog open file dialog, and under the scenes, Electron says, oh, this user is on Windows, so I'm going to use the Windows API. But there are some things that only exist on certain platforms, right? Like I talked about the light and dark menu bar on Mac, right? That only exists on Mac. So of course, the API for that is going to be Mac only. And so there are a few things like this that, well, actually, there's more than a few because there's so many things you can do to integrate your app. There's a lot. But you can check to see what is available and how customized you can get with your app by looking at the documentation, and you can see which APIs work on which platform. But again, the core essential APIs work across all platforms. And so if you're going to use something that only works on one platform, that doesn't mean like now you have to start a new code base. Most of the time you can just handle it with an if statement. So for example, on Mac, you can make your window transparent and you can see the background or whatever is behind it. That's a vibrancy setting, and so you could just set an if process platform is Darwin, set vibrancy. And so that's the extent of what you have to do something custom for your Mac users that wouldn't be something that you could do in another operating system. So it's totally up to you. Like, you can have Electron just open up another website, and that would be the bare minimum thing that you could do. you could start using Node and save things to the file system, but then you could also go down a rabbit hole of totally customizing and really integrating your app with the desktop with all of the APIs that Electron has available. And honestly, there are a lot of things you could do. People were contributing the Sierra APIs long before it came out, and when Electron first came out, or was open source, like I said, like it was built for Atom, so everything that existed in Electron was there because it was something that Atom needed and nothing more. And now that so many other people are building on Electron, you're getting a lot of great other APIs and a lot of ways to integrate your app. All right, and so I'll go briefly into what development is like for the basic Electron setup. And I've tried to, or I guess I kind of try to explain Electron development in these two ways. If you're coming from a web development background, Electron's like building websites, but you get to use Node, and you can get to think of ways to use operating system features that you wouldn't get to do on a website. And you also only have to care about one browser. If you come from a Node background, it's a lot like building a Node app, but you can build a UI for it in HTML and CSS. And you can use your favorite front-end frameworks, or not, or CSS, whichever makes you happy. You can do that. And again, I just want to emphasize that Node is completely seamlessly available in Electron. So in your HTML, in your script tags, you can just start using Node requires if you want. You can do things like checking the platform that the user is on and appending classes. And then, because you could create a whole new Windows theme, right, and a Mac theme and a Linux theme, and you can toggle those in your HTML by just checking the platform in Node, but then appending the class. And then you can read files and write them to the DOM. That's the part that is really fun, I think, and gives you the magical playland feeling with Electron. All right, so because Electron apps are a lot like writing Node apps, you have a package JSON, and in your package JSON, you'll have a field to define where your main process is going to be, because that's the first thing Electron's going to look for is, how do I start up this app? So you point Electron to your main process file, and then in your main process window, you start up your app, and you use browser window to open an HTML file. And so then you have, these are really different colors up there. You have an index.html file, and that's it. These are the three components to a basic Electron project, and they represent the processes in Electron. A great way to get started is the Electron Quick Start app, which is this bare bones, a main.js file, an index.html file that you can clone and run. And not only is it a nice way to just kind of see quickly what an Electron app is composed of, but it's also a great way to just start an Electron app, because you get an empty HTML page with the hello world, and you can delete that, and then just start writing your app. And I definitely want to mention that because Electron's also a lot like building websites, you can also make your website, your Electron apps terribly inaccessible. Please don't. Electron has a DevTools extension called Devtron. Devtron's great in general because Devtron will help you inspect your Electron apps, see where you're making synchronous IPC calls and things like that, but it also uses Google's accessibility library to audit your Electron app. And then there are accessibility tools that exist for websites that also pair well. Not all of them do, but the Khan Academy's Totally pairs really well with Electron apps, so please use it. And then I have some resources on here, and that's it. And I'll post the slides so that those links are actually meaningful. Thank you.
All right. Thanks, Jessica. That was so cool. Love Electron. So our next speaker, Soledad Panedes, sorry if I butchered that, joins us all the way from London, where she works as an engineer for Mozilla. If you're anything like me, though, you probably know her better by her Twitter handle, Supersole, or if you're anything like me, mispronouncing it horribly as Supersole. Where, according to her bio, she is a creative browser crashologist. I really like that. So in the same spirit of doing surprising things with web browsers, she's here today to show us what's possible with video and audio streams in the browser without a server, without plugins. So please give it up for Soledad.
Oh, good. Nice. Looks good. Excellent. Hi. Yeah, that was a very good pronunciation. I am very impressed. My coaching abilities have worked. Nice. So Spanish names have this thing where most of the words have the stress on the last syllable. So it was like coaching Mark with like ta 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 ta. That's how you say my name, and it actually worked. So that's really great. I'm going to use it all the time. So yeah, I'm Soledad Panedes. I'm Spanish. I work in London. So I'm not too jet lagged because I was in Singapore last week. But before I continue, there are moving images and loops and maybe awful sound feedback here. So if you have tinnitus, if you get sick with these kind of things, please leave now. I'm very sorry. But sometimes live audio and video is unpredictable. So I don't want anyone to feel unwell. So you've been warned. If you leave now, I won't be feeling upset about that. So I work at Mozilla. I found this GIF in this place called GIF Cities. There are amazing things in this website. And actually, the reason why it's so sharp and anti-alias is because I'm using a CSS property to interpolate. The original GIF is very, very small. So I'm an engineering manager at Firefox DevTools, so I'm making DevTools better. And what I really like is making video and audio stuff. So I have this website where I have all sorts of cool things I do, and I did this thing some years ago, and it's basically about using your camera to make GIFs, which you might kind of recognize because it's kind of extracted from the code of Meatspaces. So this is the kind of things I like. So when I heard that you could do the same thing with Media Recorder, I'm like, oh, I'm going to totally take that as my dev thing. So I've been researching this thing for about a year. Last year, about this time, someone from the WebRTC team in Firefox approached our team, the DevRel team, which was my team back then, and said, hey, we have this new API. You might be interested in maybe trying it out and making a demo or something. And I was like, oh, I can finally capture what I'm doing on the browser, so that's super cool. And so we started playing with that with my colleague Belen. And we found so many bugs. We also found that we didn't find documentation because there wasn't any. So we had to write it ourselves and dig into things. So after a whole year of finding many bugs, crashing the browser many, many times, and all that, we are finally ready to talk about this kind of alchemy. The whole title is very long. So streams, it's not these streams, you can't join these streams, you can actually join them. And it's not these streams either. By the way, this is a great movie. I just watched that in the plane here, and it was like, oh, this is really cool. So not those streams, and not Node.js streams, and not feature JavaScript streams either, but media stream instances. And you might be like, how many streams can we have? So it's track containers. Media streams are track containers, and probably that doesn't tell you anything, but tracks can be audio or video. So if you imagine a DVD can have several tracks of audio, and in theory, several tracks of video, so you can change between the scenes, which never happens because producers just gave up on the idea. But that's the whole idea of DVDs, and in general, streams of media, is that you can have various tracks of things. So you can have any number of tracks per stream. That was the premise that we got sold the DVDs based on. And you might actually have used media streams already if you've used Get User Media. Who hasn't used, someone has used, please raise your hand if you've used it. Okay, at least one person was aware of what was going on. Everyone else was in a cave for the last 5 years, I guess. So with Get User Media, you use Navigator.media devices. It used to be somewhere else, but it's been moved to be under media devices, so it's not polluting all the global namespace. So you call media devices.getUserMedia and say audio, true, video, true. And eventually, once the user has been asked for permissions and everything, you get a stream with audio and video, hopefully. And then you do something with it. So the usual thing that people do is just show an image on the screen, which is cool, because back in the days, we had to install Flash and all those things so we could display audio and video, and you could actually, if I connected the audio, you could listen to me and it would feedback terribly. Okay, so in theory, it should be displaying. I don't know what's going on here, but fine. So this is boring. This is all news, like seriously, only he knows about that. I mean, I'm pretty sure you're very bored, right? You didn't come here to really hear boring stuff. You can hear to the cool things. So what's even cool? The new cool thing is Media Recorder with this API I'm going to talk to you about today. It's native. I don't know why this is like earthing. It's not good. So it's a native JavaScript API, which means that it's built in your browser. You don't need to download anything. You don't need to npm install. It's built in. And also, it's very familiar. If you've used the DOM and like add event listener and that kind of things, you already know how it works. So it's great because you don't need to learn a new paradigm. So that's super cool. So in a nutshell, what you do is you have a new constructor, which is new media recorder, and you pass it one of those streams that you can get from the webcam. And you have methods, which are like very familiar and similar to like using a recorder, which is like start and stop and pause and resume. So like if you're from the 80s like me, you know how tape recorders work. So this is the same thing, like start, stop, pause, and resume. Except that tape recorders don't give you data available events. In this case, if you add a listener when data available happens, when you press stop, you will get a blob with data. So that's the modern thing compared to tape recorders. So we can use this to record things from the webcam. And the way you do it is you create a recorder with the stream that you got from the camera. OK, this is pretty readable, nice. You add a listener with the data available event. I'm using fat arrows, because why not? So you get this event, and it's got data, which happens to be a blob. And we want to set that to play in a video element, which is in the website already. So we need to create a URL, because otherwise the video doesn't know where the thing is. So you create a URL for this with this object that also exists in the window. This is just pure JavaScript APIs that exist on the browser. This is not a library. So you set the source of the video and then select play. And then this is just for setting the listener. On the other side, you have to start the recorder, and then we tell it to stop recording after 5,000 milliseconds, which happens to be 5 seconds. So if I do this thing, it starts the webcam. You can't see because the LED is not in your side, but it's recording. And now this is looping, and this should be playing my audio. So this is what recorded. And because it's a video, I can do things like changing the speed and change it to ludicrous. So it's faster and things like that. The most embarrassing one is the slow one, which makes you feel like jet lag. Yeah. So yeah, I just encoded audio and video natively in the browser, and I didn't even use plugins, which when I gave the talk all the time, they told me that this was a mic drop, so I could just like go and just like be done with that. Because I should not maybe need to tell you anything else, but I'm just joking. Obviously, there is more content. So we just barely scratched the surface. This is just the beginning of what you can do, because just like recording video is fine, but it's not fun. So more sources of streams is get user media, because this is very related to the WebRTC group and everything. In fact, it's the same people who are working on this. So you can share your screen or your windows, and you can record that, because you just get a stream from this. So right now, this is a bit weird. You have to whitelist the domain, because sharing your screen is a very bad idea with people on the internet. So right now, if you do this in Firefox, we're going to tell you, no, this domain is not whitelisted, unless you go to about config and add the domain there. We are going to change that in some upcoming release, where you are going to say to the user, are you really sure you want to share this with this domain? Terrible things might happen, la, 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 la. So in the feed, you start user media with get user media, but instead of saying video true, you say media source, like you pass it an object. Say media source, screen, or window, whatever you want. And then you get a prompt that says, are you sure you want to do this? So like in this case, I can use this to demo 8-bit art by Chance Schiffer. And suppose you want to show someone how you're using get 8-bit art thingy. So I say, OK, I want to share this entire screen. And it's like, this is what's going to happen. Are you sure you want to do this? Yeah, OK, fine. So this thing on this side is video clips I'm recording from what I'm doing here. So I can try and draw something here. And then I could send the link to someone and be like, hey, I made a video how to record this thing. So I can open this and I could just share that with someone. Like, this is how I did this thing. So you can just screen share and record that thing in JavaScript right now. You don't need to start any plugin. I don't know if you are aware of this. Like, if you've done any kind of like Hangouts, this is huge. My laptop is not taking off right now. There is no a massive battery usage to do this thing. This is very lightweight. This is great. So that was one source. You can also get a video stream out of a canvas if the browser supports this. So you have this capture stream method on browsers that support that. So when you call capture stream on a canvas, you can, this is optional, tell it how many frames per second you want to capture. And then, again, you create a new recorder using the stream that you got. And if you're into drawing pixels, this is very interesting. You get a buffer of pixels. You go through them. You add some values, la, 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 la. I'm going to skip that. And then you put it back. And then you also do record the start and stop and everything. So what I'm doing here is some kind of magic. And I'm going to generate a clip with white noise, which is going to like... And then that's a video. So imagine that you have a game and you need a clip of white noise because there is a TV on the game and it needs to be showing a video of white noise. Instead of sending the video, you can generate that on your game so you don't make the people use their bandwidth for generating a stupid clip. So that's cool because you can get like really high resolution and not having to send the thing all down the wire. So that's really cool. And this is generating, but what we could also do is transform the webcam images with the canvas methods before capturing that. So I'm going to do this in 2 steps. First, I'll show you how to manipulate the images, which is the same. You get the context, the canvas context, and draw the video, which you got from the webcam, into the canvas. Then you get the image data from the context, which is here. So that's the pixels without being the original pixels. And then you do the same thing. You are going through every pixel, and we're applying this cutoff thing, which I can change here. So that makes me look less, or like depends how much sun I've been taking, right? So this is the cutoff thing. So that's what I'm doing. I'm just like changing pixels, not capturing happening here. This is a very simple filter. But now, if we want to capture this thing, what we need to do is call capture stream on the canvas that we are applying this drawing to. So some steps from before, we init the webcam, make the video stream, we copy the canvas, la, 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 alter the pixels, which is why I'm here in black and white. We also get the stream from the canvas, and eventually we call me the recorder with the stream and record. So I'm going to do this thing here. So this thing is now recording. The feedback of this demo is very bad, but this is me being recorded in a video, like very dark and sinister. Yeah. Actually, we did most of these demos before Halloween because we wanted to like make scary things. So that's why they have this sinister theme to all of them. So yeah, we have manipulated things and recorded them. So we can you could send these kind of things to your friends, and you could even share them in Twitter if only Twitter understood WebM, which it doesn't because apparently they don't know how to do FF and PG. So anyway, you should not actually use Canvas. It works because this is a very small buffer. This is very small filters. We are not getting super complicated, but what you should be using is WebGL. But WebGL takes so long. Like just setting that up would be like half of the talk, and you don't want to, so no. So stream sources. We have a third way, which is the one that I really like, and it's called media stream audio destination node. And we used to make fun of Java class names, but the problem is that it's very descriptive, but it's also very long. So what it means is a media stream for audio, and it's the destination type of node. So these kind of nodes have a dot stream property. And probably you have not much idea about web audio. So what we do is choose this node in the context of a web audio context. And so we can modify and capture the audio and do all sorts of things in real time within the web audio context. And what's the web audio context? It's the door to the power of web audio. And web audio is this magic thing that lets you connect nodes that you can create, and some of them generate sound, some of them modify sound. You can route, you can split things, you can join them together. It's amazing. It's very long to explain. I've done many talks that explain these things, so if you want, you can watch them, or you can ask me questions. But basically, this is how it looks like. Like, you have this kind of graphs. And in this case, we're going to use one of those sources, which is going to be the microphone. We're going to do some effect, some magic. And then we will create one of those very long node names and take the stream property, which is a stream, and connect that to a MIDI recorder to record this thing. So we're going to do input stream, audio context, which is the black box, which makes effects. And then we get the output stream. But that's a bit too much to take on to start with. So I will just start with the input stream. How do we make this thing into the context and then record? So we ask the microphone. We just get user media with just audio equals true. And so we got a stream. And then we create an audio context, which is how you create a web audio context. It's kind of like a canvas context, but for audio. And then we create an input node, which is create media stream source. Compare this with source destination. So you have the source and you have the destination. One is for getting streams, and the other one is for getting streams in, and the other one for getting streams out. So we have this function called make effect, which makes a black box that makes sound effects, and then like the guitarist pedals. So we will connect the input node to the effect input, and we connect the effect output to the audio context destination, which happens to be mapped to the speakers. And you will see or will hear some effects, hopefully. Hi. This is the feedback I was talking about. So this is an effect. This black box is like making some kind of echoes. Cool. We want to record this. So the way we record this thing is instead of connecting the output to the destination, we will connect the output to a node which has a stream property, so we can use that stream with a MIDI recorder. So we add this media stream audio destination node to the context. So we have this thing from before, and instead of connecting to AC destination, we connect that to the output node, which is this. And then we just take the MIDI recorder and say output node.stream, which is the property we want to record, and then we just record. So I'm recording, so it says recording here. And eventually we'll stop, and I can play this. So it's been processed, it's been recorded. But this time it's not feedbacking even more, because this is just the thing. So we've been able to apply effects in real time to the thing that we were doing. So if you're doing any kind of web audio thing, you could capture that and record that thing, and then you just get like an OGG file, and you can send it to your friends, which is great. And again, maybe you could share that in YouTube, but I don't know if YouTube supports OGG. Probably they do, because they're not Twitter. So we've looked at how to do video and audio, but separately. And possibly, if you're like me, you want to do everything at the same time, and the more the better. So the problem is that what we're doing so far is we always ended up with the stream from the canvas and the stream from the web audio context. But the MIDI recorder, so far as we've seen, only takes one. When you do the new MIDI recorder, it takes just one stream. So how do we join them? Because in this case, it's good to join these two streams. So how do we do this? So this was the thing that took us longer to find out, because there wasn't any demo. So they were like, oh, you can do all those sorts of good things, but no one would think of documenting this thing. So eventually, I remember that I just opened the console and started doing like new media stream. Oh, that was good. The media stream worked. Which apparently you have access to the constructor, which is what we needed, because once you have access to the constructor, you can use the methods, which is get audio tracks and get video tracks and add track. So I could create a media stream and then just move things around and mingle things together and recombine them as I wanted. So the good thing is that MIDI recorder doesn't care. As long as you give it a stream, MIDI recorder is super happy, and it's going to be chugging along and recording and super. MIDI recording is very obsessive of recording. So this is like a deconstruction of what we would do. So if we want to do these two things, and eventually result in just one stream, we start with the input stream, we get the video tracks, and then we do media stream, we add the video tracks to the media stream, with that track, and then we manipulate with the canvas, and then eventually you get a stream from this. And it's important to separate. You would say, like, why do you want to take the video tracks out? And it's because if you want to manipulate video, you need to have the video playing. But you have the video playing. The problem is that the video that you're playing is also playing the sound. So if you want to manipulate the sound, you're going to be listening to the original unfiltered sound plus whatever. So it's very strange. You better have a video without any audio tracks, so you can play and then get the frames one each time. So that's why we had to separate. Because if you mute that video, you don't get any sound into the soundtracks. It's all very complicated, and it could be so easy. So then on the other side, you extract the audio tracks, pass them to your web audio context, like after adding them to the audio track thingy. And then, again, you get a media stream, blah, blah, stream. And finally, you just create a new media stream and add all the tracks with all this monumental for each kind of loop. And then finally, you have all the tracks, like audio and video in the output stream and media recorder output stream. Finally, so we are done. And the question is, why is Solid so excited about this API? Well, because you can share things with your friends, but unless you give them, like, unless the website you're using has like a proper URL kind of like generation, so you can give them the URL and it reproduces exactly the same thing, they cannot reproduce the same setting. And some things you cannot really like put in a URL. It has to be like a very long URL. So sharing sometimes is not very easy if there's too much data you want to have. And sometimes people just can't even play the thing. Like if I make a thing which is very processor intensive, I cannot give them a URL to a very long thing and make them play that in their small phones without battery. So it's important to be able to record the things that we're doing in the browser. And also because, you know, like people like Matt McKeck might want to capture what he's doing natively instead of having to do workarounds and things like that. So if you want to move things to the web, we need to have like a feature-complete browser. So this was one of the most important things that we needed. And this was something that we kind of like implemented a bit when we have Firefox OS, so we could record messages and ringtones. So this has kind of like been for a while in Firefox, but it was just kind of like incomplete. Like you have some audio, I think Chrome had some video, but like obviously if one has video and the one has audio, it's not like a very compatible API. But finally last year they got together and Chrome and Firefox have been working like really hard to get this thing to a point where it's usable. So it's important because you can finally build this kind of sophisticated apps without plugins or server-side. And it's really fast because you don't have to send uncompressed data over the network because uncompressed data is really huge. And also because sometimes if you don't need to send the data at all, you can just encode things in the server, like in the front side. So you don't even need to send whatever it is that you're recording through the wires. So you can be, you know, like actually private. Like, and if you use service workers, you don't even need to get it up again because it's already offline. So you can record things and encode them, and you don't need to wait until you're online to get them into a shareable format. And also, I think that photography and video apps are kind of a big deal. Like in the Play Store, Snapchat is the 4th and the 5th app. This could be the Australian Play Store. I don't know how geographic things work. I wasn't signed in. But in the App Store, in the iOS, this is my phone. I have 29 updates to update. I just hate installing updates. Well, Snapchat is the 6th, and Instagram is the 8th. So it's like really massive. And YouTube, does it count as video? Maybe. OK, YouTube is the 5th. So they're a big deal. Like people like taking selfies. And I don't know. I don't think anyone here is from the UK, but there is this thing they do in the TV where they show some interstitials with people that recorded their faces with selfies and Snapchat. It's terrible. I hate that. Yeah. But yeah, Snapchat is big, and people want to have fun times with their phones, but we want things to be in the web. So if we want things to be in the web, we need to give people APIs where they can do these kind of things. So what I'm saying in other ways is that you can build Instagram and Snapchat in the browser thanks to Media Recorder. So that's huge for me. But maybe we don't need another one of those. Maybe we could get more creative instead. So for example, I did get creative. I built this thing, which is kind of like museum-like. So if it doesn't crash, which I think is the case, because, beta. Hi. Yeah, it's crashed. I'm sorry. It used to work really nicely. OK, let's try again. At least it didn't crash the whole thing. So let me tell you about Firefox ETNS. It's the electrolysis new thing. In theory, it's designed to avoid the browser crashing completely, but I think it's taking over the whole thing. And I've even reset my computer this morning, just in case. OK, at least I could close it. Could I? Are you gone? Have I shown you my fantastic collection of memes? This is the meme says you've been mansplained. As you can see, mansplained here. OK, can you please go away? I didn't have this thing just in case, but it tends to be really useful. OK, let's try this thing again. So what I was saying is that this thing is very creative, very cool. Please show my presentation. That would be nice. Which number was that? 50. Not bad. So yeah, getting creative. Please don't crash. OK, that's better. So in theory, this is kind of like a museum kind of thing. So you can have this thing, and it starts looping. And I'm pretty sure that kids love this. And the good thing is that you can start making rhythms if you tap the microphone at the right time. Sometimes it works, sometimes it doesn't. It depends on how fortunate you are. But yeah, OK. So this is one of the things you could do. And then last weekend, this is another of the things you can do. It just records kind of like, I warned you that there will be glitches. Can you please stop? Yes. So. So this is, it just takes the, it just records a very short sample, and it doesn't kind of like, how's this thing? With file reader, you can decode the blob and bring it back into WebAudio and read it as a sample. It's a bit of a strange detour, because it should be easier, but I just wanted to prove this was possible to people in the WebAudio Hack Day last week in Singapore. So the idea being that you could just record samples and do like kind of like a beatbox or whatever. But I didn't have time, so I was just like, OK, I will just record this thing and play random volumes and frequencies. So it just takes the thing and applies kind of like pitch bending to the thing. So I found that it was funny. So some more ideas, because I have more ideas. And the reason I opened the DevTools was to invalidate the cache, because it was loading some old version. Yeah, send the report. So some more ideas. A beatbox, you could do a beatbox. You could also do sample-based music apps, which is not just like a beatbox. It's kind of like a different type of, like you could do like long track kind of thing. If you combine it with WebMIDI, which is like for controlling keyboards and all sorts of instruments, you could like trigger the samples and different notes with WebMIDI. Sadly not in Firefox, but if this media recorder worked nicely with Chrome, we could do it more reliably. But anyway, so dictaphones, that is an app that we have for demoing this, which is a dictaphone, but it's kind of ugly, so maybe you can do a nicer one. You could do field recording. It's about going to places and recording the sound of this place. And you could use the geolocation API to combine everything together. There's this website called freesound.org that's got many, 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 many samples. You could also do the Vine app without app, especially now that they are closing it down. You could redo this thing. If you use the pause and resume method of media recorder, you can do the same thing that Vine does. And you could do granular and glitch-based audio synthesis, which is a bit of what I was doing. Like if instead of playing the whole sample, you just play a small grain, which is a small bit, you can do very interesting effects. And it's very, 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 let's say that it's very absorbing. You can spend hours doing that, finding the best grain and whatever. Because I am very into music, so I kind of like, as you can see, I've kind of like moving to the web audio side of things. But like last week when I was showing this API to someone else, he was like, oh, I really want to record, like he had a video and he had like he had a curve so he could control the speed of the video, and he had recorded himself like skating, so it was like a really cool video. And he wanted to like slow it down, like, you know, like very impressive things. He wanted to record that thing, but it turns out that for some reason, the video recorder doesn't take into account the speed of the video, so we found a bug. So we need people to have weird new ideas that I would never think of because I don't skate, so I would never have an idea of playing myself with my skating things. We need more ideas to break it and make it better. So if you want to do these ideas, I'm happy, but if you want to do your ideas, I'm even happier. So possibly some people are still uncertain, like, I need more examples. I have more examples. So we built this whole demo, again with my colleague Belen, who's in Spain, in sunny Barcelona. So this is about a photo booth, like the iOS thing, but in the browser. So you have effects, and this is, I call it the C64, the Commodore 64. And this is pixelated. This is very easy as well. This one is the same one from before, but with WebGL, as you can see, it's like bigger. You can use the whole screen without slowing down. This one is creepy. And because I really like the aesthetics of this JS Conf, well, we don't have the dots here, but I really like the aesthetics. So I tried to make a shader that would look this. So this was like, oh, this looks pretty nice, but it doesn't actually look like the JS Conf style. So I kept removing details, and I think this looks pretty much like that. So I was really pleased with this. And the cool thing is that you can actually record a clip. So this is using effects. So I can record something, and it just counts down. There is then la 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 on the top. So I don't know if you can see that, but there's a small progress bar, which is finishing now. And then you can download it. You can get a blob that you can open with VLC because, you know, WebM. And whatever WebM thing is. OK, there we go. So this is the thing I just recorded. Let me close this, or we'll get to. So yeah, this is the thing that we just recorded in the browser. This is amazing. Seriously, have you ever done this thing? Like, I saw people trying to load what they were doing. They were trying to compile FFmpeg into JavaScript using mscript and trying to load that thing in Chrome. And I tried it with a very powerful MacBook Pro, and it just like started taking off, and it didn't work. So if we can do I mean, this is a very ridiculously underpowered computer, and it doesn't even sweat it. So it's very, very great that we can do this. So this is very cool. There is also something that someone else built. He is not using WebGL. He's using a web worker. So he's doing all the processing on a canvas on the web worker. So what he does is, if this is, yeah. So he's got this video of the Cookie Monster. I just love him, with a green background. And he's got some cookies here. And obviously, what does the Cookie Monster like? Cookies. So when I play here, it's going to combine the two together and capture that into a video in which the Cookie Monster is got a very nice backdrop of cookies. So yum, 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 and then it's got cookies in the background, which is amazing. And he's done that thing on the background with the web worker, so the UI is still responsive and everything. So that's cool things. I don't even know this person. I just found this thing on the internet. What is my thing? There we go. So this is very cool, but there are always buts. And I was talking to Colin before, like I am very honest. When something is broken, I'm not going to tell you otherwise. Support is, Firefox supports everything I showed you. Sometimes it crashes, as you could see. There are weird things going on, but the problem is that this is touching many things. Like, there are so many machineries underneath that it's kind of normal that things break. Conf 57, which happens to be Canary, if you're Canary today, maybe next week it's not anymore. Supports pretty much everything, including streams from WebAudio, which it didn't support up until like 2 months ago. But things break sometimes. I filed the bug on Sunday that I found. I got the message that they fixed that today, which I'm very impressed. Hats off. I'm very impressed. But it was like a really bad crash, so it's good that they fixed that. But yeah, bugs. There are bugs. Safari. Internet Explorer, I don't think they will. I think they are scared of touching the code of Internet Explorer. But Edge said that they were under consideration, so that's good. I think also one of the editors of one of the specs is also from Microsoft, so it would make sense. In mobile, it's a bit. I don't think there is proper hardware accelerated encoding yet. And I have no idea about Windows Phone or BlackBerry. I saw one person with Windows phones the other day. I was going to ask, like, how do you find it? But I thought it was a bit weird because I know this person. So I was like, I would just refrain. I'm just so curious. I don't think Opera Mini is going to support it because, they strip everything out. So I don't think they're going to do this. And definitely not Lynx. Lynx, for those that don't know, is a text browser. So unless they use one of those text libraries, I don't think they're going to use this. But who knows? There is always Linux people. So it's, but like it's getting great very quickly. Like last year, this was a landmine. Seriously, whatever you did would crash or it would just not work. Like videos would not loop. Things would not record. You had to tell it to record with video and audio. If you just wanted to record video, it would not work. Things would not work at all. There was no documentation, but now it's so much better. So, but we still need people to find use cases that we never thought of. So use it, break it, file bugs. If you don't want to file bugs because you find bugs still less scary, just tell me and I'll do my best. And request features. Like sometimes people ask me for things which I don't find it useful, but when people ask things like, I would like to provide my own encoder, that makes sense, because maybe you have like a very strange, compressed kind of encoder that is not really provided by the browser, and maybe they shouldn't, but they should let you hook into your machinery. So there are features like that which I have transferred to the media recorder group, or I can tell you where to go because they use GitHub, so you can do it, and I don't get to be the bottleneck, so that's great. And there are more resources. Like I brought this blog post, which is pretty much this talk, but in like a more composed way. There is also a lot of examples that my colleague and me wrote, like a lot of examples looking at every single thing, like how do you get a canvas stream, how do you use the media constructor thingy, how do you record the video. So it's got comments as well. Would you believe that? And also, no, I didn't want to click. Go back. It's there, but you don't see it. There is the video booth, and there is also the documentation that we finally have. The Get User Media test patch is very interesting. It's put by the people that implement WebRTC. So if it's a way of checking that you're using the right syntax, because that's the syntax that comes from the implementers. I sometimes blog about this thing as well. I still have a blog, and it's not in Medium. And the slides are here as well. I actually put them online. All the updated version is online, which I uploaded this morning. And so if you go there, you can use this. Please don't go with a mobile phone because it's not designed for mobile, and maybe just, it might not even work with Chrome because, it depends on the version. But I will tweet this, don't worry. And thanks, and that's it, actually. I can go now. Can I disconnect this? Is it safe? Okay. You don't want... Yes, you got it.
Now you know why they call it Supersol. Everyone give it up. Friends, I have so many things to tell you, and it's all good news. Let's see, first cab off the rank. We just had two amazing ladies, right? I think we both, you and I, or whatever, I think we agree that they were pretty great, and the good news is that we have ladies for the rest of the afternoon, and that's pretty fucking special. Something that we are incredibly proud of is that we ran an opportunity program for this conference and for a CSS conference yesterday. And what that involved was we put out a call to say if there are people amongst the community who could not, for some reason, make it to these conferences. There was some barrier ahead of them, or they needed a break, or they needed an opportunity. And we put the call out to our sponsors, and we put the call out to the community. And 2 companies came ahead, Envato and Thick, both of which have a strong showing here today. And a couple of private donations as well. And with that, we have 14 people who had tickets who would not have been able to do that otherwise. So I think that is phenomenal as well. So huge hand to those people and to those 2 companies who helped us there. Right? It's great. Who's spoken at a conference before? Not a lot of you, but let me tell you something. Australians are great. We have some really, really great people in this community, and I've just been told by Christina that CSS Conf and JS Conf EU have their call for proposals open now. Until the end of January, you can get a proposal in. And basically what that involves is you get to go to something that's almost as good as this, but in Europe. And that's pretty great too. If you have thought about putting in a proposal, but you're a little bit unsure, if you want to get in touch with our team, we will help you. Because it's really great to see local people go and kick ass over there. So definitely do that. And I think the only thing I have to tell you is that there are suites outside, and that is phenomenal too. So go and have a break. It's 30 minutes, and then we're back. Cheers.
Is everyone back? We've got another WebVR presentation. I'm going to completely butcher this pronunciation, but Michaela Lear, excellent, is going to give us an introduction to WebVR. So this is without A-frame. Do you want to come up? Round of applause. So yeah, we've seen one with A-frame. I'm looking forward to seeing this. I'm doing a WebVR project myself at the moment, so I'm really interested to see the basic underlying technology.
Thanks, Mike. Hi. Hi. Yeah, as you already know, I'm Michaela, and I'm here to talk about WebVR. Reading the topic of my talk, you might have thought, web in 3D? Isn't that nonsense? Isn't thinking and talking about a virtual reality web nothing more than ridiculous? And most of all, should I even care about WebVR? Well, you might have guessed already, I'm here to tell you that you should care about WebVR. Even if you're not a gamer, even if you're just not into virtual reality, or even if virtual reality makes you sick. Why, you ask? Because if this technology is permanent, and at the moment it looks like it is, because virtual reality will have a great impact on our users. And we all agree that we should care about our users, hopefully. This is why I will tell you today the most important facts you have to know as developers about WebVR and VR to create responsible virtual reality experiences. I'll begin with some brief information about the hardware and VR concepts, and then we'll have a look into the WebVR API. And afterwards, I'll come to the topic I'm most passionate about, a good user experience in WebVR applications. Before I forget, you can all download the slides with all the code and links. I will give you the URL at the end of the talk. So, since we only have 30 minutes, I won't talk about what virtual reality is. And I also won't talk about why I think virtual reality matters. Instead, I want to concentrate on the things we as developers have to know when we want to create a virtual reality application. So let's begin with a look at the hardware. First, there are mobile VR devices, which are basically smartphones and relatively cheap headsets with magnifying lenses. The input methods on these devices vary. We have, for example, on the left, the Google Cardboard, which has only one button on the side. And there's the Samsung Gear VR, which has a button and a touchpad on the side. And on the right, you see the newest one, the Google Daydream View, which comes with a special VR controller with 3 buttons and a touchpad and volume controls. There are also desktop VR devices. They are significantly more expensive because they also contain the sensors and the screens. The computing power comes from the desktop computer or the gaming console to which the VR device is plugged. The input method of these devices also vary. The Oculus Rift users can use Oculus Touch motion track controllers, and also the HTC Vive ships with Steam VR motion track controllers. On the right, you see the PlayStation VR. You can use with the PlayStation Move controllers. There are also standalone VR devices in theory, which contain not only the sensors, lenses, and screens, but also the computing power. At the moment, this is only theory because there are no really important devices on the market right now. But of course there will be, because this may be the most convenient form to use virtual reality applications without any plugs and cables, but a higher computing power than a smartphone. So now, as developers, we need to know about the different hardware and VR concepts when we want to not exclude users. So let's talk about the most important concepts of virtual reality: stereoscopic images and tracking. We'll begin with stereoscopic images. When we talk about stereoscopic images in the context of WebVR, we are talking about two images next to each other showing the same content, but from a slightly different point of view. The offset between both images is called IPD, which means interpupillary distance. By showing these images to our eyes, we are exactly recreating how we see the world naturally, and our brain combines these images like it always does and gives us the perception of 3D depth. When we are looking at WebVR images, we often see not full-screen images like these, but some kind of distorted images like this. We need this effect to compensate the distortion the thick lenses are making to the images. If we wouldn't have this distortion, the images would be distorted like this on the right. But if we apply a contrasting distortion to the original image, the images behind the lenses will be without any distortion again. So, by showing these slightly different images to our eyes, we are already getting the perception of depth. Now, to make our brain believe we are actually in this virtual world, we have to include tracking. All VR devices I've shown include 3 degrees of freedom tracking sensors for the rotation around the 3 axis. More advanced VR devices, for example, like the HTC Vive, also include tracking for the position of the user in a room, which is called room scale VR. You can surely imagine that the more tracking sensors we have, the more intensive is the feeling of actually being in a virtual world. This immersive feeling gets even stronger if we include input controllers with rotation or position tracking sensors. Now, how do we create such applications in JavaScript? Let me show you the stack we'll be working with. First of all, there's, of course, the browser. Then, with WebGL, we have an API for rendering GPU-accelerated 3D graphics in the browser. We heard about this morning in Jess's awesome talk. Now, we need to get access to the head-mounted display and the sensors, and therefore, we have the experimental API WebVR. On top of this, there may be further JavaScript libraries. One common library to reduce the effort of writing WebGL is Free.js. Now, let me show you this technique in a simple example. Here we have an obviously distorted 3D spherical video, which I recorded with my 360-degree camera. What we want to do is play this spherical video undistorted and in a stereoscopic way. Also, we want to use the rotation sensors of the devices to let the user look around while the video is playing. So our setup could look like this. We have a 3-dimensional coordinate system where the camera is the user. Around the user, we will create a large sphere, which will be our video canvas. So a simplified version of this code could look like this. Everybody who is familiar with WebGL or Free.js see nothing new here. First, we create a scene and the camera. Then we create the sphere with the video texture. And then we render it all to the canvas within the render loop. This is only WebGL or Free.js. There's no WebVR here at the moment. So how do we render this scene not on the default screen on the canvas, but on the head-mounted display? This is where the WebVR API comes into play. First, we need to get access to the VR device. Therefore, we use the Navigator interface extension, getVRDisplays. It returns a promise that resolves in an array of VR display objects. And one VR display object represents one VR device, which holds then information about the VR device. For example, if the device is currently connected, if it is presenting, and it also has methods like get eye parameters, get pose, request present, submit frame, and request animation frame. We can then use the VR display object to render content to the head-mounted display by using the request present method. Request present takes an array of VR layer objects which have a property source containing the HTML5 canvas we use to draw on. The cool thing is about request present is that it handles device-specific rendering issues, like, for example, the barrel distortion I've talked about. So you don't have to implement this stuff manually. And another cool thing is that, another thing you have to know is, which is not so cool, obviously, for security reasons, this request present method only may be triggered by a user action. You may compare request present then to request full screen. It also requires a user action, and request present first requests that the VR device goes full screen. So you would probably write something like this. Request present also returns a promise that is fulfilled when the presentation has begun. And this is then the time we can start the render loop by using VR display's request animation frame method. VR display's request animation frame is equivalent to Windows request animation frame, but it has device-specific features for rendering on a head-mounted display. It also draws continuously on the canvas, but it does this in a higher frame rate, depending on the VR device, not with 60 frames per second, but with 90 or even 120 frames per second. Within the render loop, we are first scheduling our next frame's callback, and then we can update our scene and camera position and rotation, depending on the VR display's tracking sensors. Therefore, we have different interfaces. There is, for example, the get pose method, which returns a VR pose with lots of information of the sensors at the moment. For example, there's the user's orientation, which returns a quaternion, or the user's position, which returns a 3D vector. The mobile VR devices will return for a position null because, like I said before, it has no sensors to know where a user is in the room. Now we have to render our scene twice in a stereoscopic way, and this is where we can use the get eye parameters method. It gives us all the information we need if we pass one string for each eye as an argument. So there's the offset, which is 1/2 of the interpupillary distance, or the render height and width, which returns the recommended width and height of a canvas for each eye. With this information, we can update our cameras and scene and render it all to the canvas by using the submit frame method. And this is basically all you have to know and to do to get our video playing and updating while the user changes her pose. So now, let's get back to the stack, because I want to give you also some practical tips about the libraries we used to create this prototype. We didn't use A-Frame, but we used Free.js. So you might have already guessed it. You are right, WebVR, the API isn't ready today. There's a good website called iswebvrready.org where you can see the current implementation status of the API. So fortunately, as long as the API isn't shipped with our modern browsers, we can use the WebVR polyfill. And there are some small but really useful libraries that add support for the VR controls and the stereoscopic rendering to Free.js. Last but not least, We used the WebVR Manager from the WebVR boilerplate by Boris Smoos from Google, which adds some basic cross-browser support. Okay, talking about cross-browser support. In a perfect world, our prototype would work within every browser, but of course with less features in older browsers. So, for example, a browser not capable of WebGL would get a static image, and a browser capable of WebGL would get a 3D WebGL application that works with the mouse or the keyboard. Then, on mobile devices, we want to make use of the touch input, and more importantly, the gyroscope, to create a more engaging application. And of course, a browser capable of WebVR gets the full WebVR application with all the WebVR features. One issue with WebGL and WebVR apps is definitely the long loading time. We have large textures, images, videos, 3D models, so you want to include mechanisms like progressive loading in your application. Now, as you've seen here, we not only use the WebVR API, but also the WebGL API to create this prototype. And let me tell you, you'll be using more APIs to create a full WebVR application. First of all, there's the Gamepad API. This has already shipped in modern browsers, but it will get more features for handling VR-specific gamepads, like, for example, the Gamepad hand method to discover in which hand the gamepad lies, or the gamepad pose interface to get the orientation, velocity, position, and acceleration of the gamepad. Then there's also the Web Audio API we can use to create and add spatial sound to our application. And the last API I want to mention is the Web Speech API you can use to avoid the very uncomfortable way of typing into a keyboard in VR. Well, because I think we can all agree that typing into a keyboard with a headset on, or even worse, I find it even worse, clicking single keys with a pointer on a digital keyboard is not the best way to make text input in VR. These are only two examples, but I think overall we should talk about user experience design in VR application, because the way users interact with the digital world changes dramatically in VR. Bo Cronin, I hope I spell his name right, Bo Cronin has created this hierarchy of needs in virtual reality, which I find very compelling and a good guideline to prioritize our focus when we are creating VR apps. So the hierarchy shows that the most important needs in VR are first comfort and interpretability, and only afterwards comes usefulness and delightness of an application. So comfort means that a user can use your application without feeling unwell, and interpretability means that the virtual world feels convincing to the user. If these both needs are satisfied, the user will get the feeling of actually being present in this virtual world, and this is what we want to achieve. So we cannot talk about all needs. This is why I will focus on comfort and begin with some basic facts about ergonomics. Our VR application does not have a limited viewport. On the contrary, we have an infinite canvas, and the user has only a limited field of view. This field of view may change because the user can rotate her head and look around. So some smart people found out how big this field of view actually is. If a user is sitting, she can see a 70-degree circle in front of her. And then, with turning the head to each side, comfortably around 30 degrees, or with stretching max 80 degrees, the range increases to 230 degrees. Of course, we could turn around and bend much more, but this means your main content should be within this range if you want to have your user engaging with it without effort. One other thing you have to remember is that we have the best depth experience if the content is not more than 20 meters away and not closer than half a meter. So everything closer than 50 centimeters will make us cross-eyed, and you don't want this. Since the devices at the moment have a relatively low amount of pixels per degree, we also have to use large font sizes. Most designers agree that it should be over 20 pixels. One word about PPD, which means pixel per degree. The devices at the moment have around 10 PPD. And a good resolution to not see any pixels anymore would be 60 pixels per degree. So this is then the time you can stop worrying about anti-aliasing and use smaller font sizes. Now, we know where to put our content to make it comfortably visible for the user. What can we do more to make our users comfortable? We can avoid eye strain by using darker colors. And we can avoid focusing on different depths. We can also avoid creating environments that may trigger phobias, like large empty rooms or rooms where you're standing on a stage. Or small rooms, messy spaces, heights, and underwater environments, for example. Also, we should use correct scales, and we do not want to move things fast towards the camera, especially sharp or dangerous or pointy things. Also, we do not want to attach things to or near the camera, so head-up displays are not a good idea. Then, now, what about the elephant in the room when we talk about virtual reality and comfort? What about simulation sickness? Making a user sick, causing him or her physical pain, or making him or her even throw up is hopefully the last thing you want to do as a developer. Now, what can we do to avoid simulation sickness? Simulation sickness occurs, it's really dark. Simulation sickness occurs when our sensory inputs are not consistent, which means, for example, when the simulation tells us we are in a car race and we are actually just sitting still in a room. There are some best practices to avoid simulation sickness. First of all, don't use acceleration. Then, don't move the horizon, and do not force movement on the user, which means do not move the camera. If you want to create animated scenes, you should allow additional head movement. So, for example, put the camera on a dolly and then animate the dolly. Also, keep always head tracking and watch out for a low latency and a high frame rate. Avoid flicker and blur because they indicate movement, and you may consider adding a stable focus point. Your application should support short usage, so save states or make it offline capable. And consider using more abstract patterns than realistic ones. For example, flying cartoon hands will work better than realistic arms and hands. Or another example is that a walking simulator will make more people sick than a flying spaceship simulator. This is because we know really good how walking should feel like, and a slight difference can make our brain confused and the user feel unwell. We could talk about this all day, but time's flying by, and we want to get back to the web and VR. We are in a kind of similar situation like in 2007 or 2008, when the iPhone and with it the first mobile sites appeared. Back then, we had to reconsider how we present our content on a small screen or on screens with various sizes and ratios. And now, we have to think about how we present our content when there's no more separation between the user and the application. Our users are finally in our applications. So at our company, we try to get insights about this by using the example of a simple image gallery. How would an image gallery look like if the user was in the application? I think that the VR web comes hand in hand with losing our UX design metaphors, because we all agreed that an image gallery, of course, would be a gallery with images in it. So this is our application. A user can look around and move and see all the images. Try it. It's a prototype, but you can try it. I will give you the URL also at the end of the talk. Okay, let me ask you one last question. What about the future? At the moment, there are some smart people developing the API, and they are also thinking about making the VR web usable without WebGL and JavaScript, but only with HTML and CSS. For example, we could think about making our websites visible in a 3D space and let the developer decide with CSS how the spherical image around the user should look like. Or, like A-Frame does it, we could think about tags for 3D graphics that contain also the textures and the animations. Or what about media queries for VR user agents? There are no actual proposals at the moment for these mechanisms, but I think we should keep in mind that the VR web is not uniquely defined yet, and you all can be part of shaping it. So, if you like it or not, as a developer or a designer, you are at least partly responsible for the well-being of your users. And with a VR web, you might not be responsible only for a low battery or high telephony costs anymore. With a VR web, you could cause, like I said, actual physical and psychological pain to the user. We talked about throwing up. We could also imagine like running into walls or falling, which is also what I was afraid to come here on stage when I think about it. But let's be serious. Even worse, we could trigger paranoias and not prevent that scary or abusive material appears directly in front of a user's eye. This is all way more serious in 3D, where we try to make our users think that they are in another world, and then this world is violent and hurts them. So there's a study I read about, and that lets people in VR be a superhero, and then put these people and other people in a situation where someone needed help picking up dropped pencils. And the people who were a superhero in VR actually helped more often and faster than the others. So you see that your content and how it is presented matters. And this is why you all matter. So be responsible and be aware of this. Yeah, I have many resources for you in the slides, and also a list with interesting people you could follow if you're interested in WebVR. And this is the URL to the slides and the prototype. And there's also a newsletter about WebVR. If you like, subscribe to it. That's all. Thank you.
Thank you, that was great. Lots of information in there for everyone. So let's just take a moment to think back about the day. From the opening speech, it's been pretty much mind-blowing. It's kind of good to remember how awesome our community is and all the things that are happening that make us excited about what we do. I know for one, I don't get to play with things like this in my day job, but I'm pretty much maybe thinking about skipping the party to go home and try some of these awesome things out, but maybe not. Next up we have Ruth John, and she's on a bit of a world tour. She's come to us from a small little place outside of Bath in the UK. For those of you that don't know, Bath is the setting for a lot of Jane Austen novels. But that's not Ruth. That's not Ruth at all. Ruth is a coding artist. She's a Google developer expert, and she has been yarn bombing the tech industry since 1981. And today, like she did at Singapore JS recently, she's going to blow our mind and show us how to be a web AV artist. Welcome, Ruth.
regulators. We regulate any stealing of his property. We're damn good, too. But you can't be any geek off the street. Gotta be handy with the steel, if you know what I mean. Earn your keep.
Regulators! Mount up!
Oh, timing, that is so hard, right? Hey, JS Conf Australia! Yes! Thank you very much. Hello. I am Ruth. That was it, I'm done. Thanks. No, I'm joking. Oh, no, I like that intro. Normally at the top of a talk, people would introduce themselves, sort of say what job they do, what sort of credentials they have, what they do day to day. I kind of think it's probably easier if I just show you. So that's what I'm going to do. So I'm here today to talk to you about being a web AV artist. I know, right? What? Like, what even is that? To be honest with you, I kind of struggled with the practicality of this talk. I was sort of sitting at home and I was like, they're gonna listen to some crazy stuff, and they're gonna go back to their jobs, and they're gonna be building websites and web apps and progressive web apps and web things and all the things that they do. They're not really gonna be doing audio visuals. They're not gonna go back to their jobs and be like, hang on a minute, I'm just gonna put some AV in this website. It's gonna be super cool. Did anybody see this Venn diagram that's going around the internet recently? The Practical Dev tweeted this. I just realized I've forgotten my coffee, one sec. Have a little read of this Venn diagram. Coffee's important. Thanks. So on the right there, we've got like what is in conference talks, right? And on the left is what is useful to be in conference talks. And as you can see, there's no overlap. So I was thinking to myself, what I could do was make two lists based on the diagram. So this is on the left, these are things to avoid. So these are things that happen in conference talks, which if I can avoid in this talk, it'll be useful, because I can include all the stuff on the right. So that's all the stuff that will be useful to you as developers, right? So avoid analytics, operational excellence, chat ops, orchestration. I think I can avoid that stuff. That's great. But I do have to include duct tape, workarounds, bike shedding, coffee. Right, cool. Okay. So now we've got the talk anxiety bit out of the way, and I know what I'm going to have to include and what not to include. We can begin. What is a web AV artist? So AV stands for audio-visual, right? So audio-visual artist is somebody who sort of puts visuals or creates visuals based on audio. So it's a little bit more towards the visual end rather than the audio end, even though we do work with a little bit of audio. Another word for this is VJ. Does anybody in the audience remember this?
Winamp. It really whips the llama's ass.
Yeah, cool. People are putting their hand up. That's so brilliant. But any of you that don't remember, I can see some young faces around. In fact, I thought most of you were, actually. This was the MP3 player of choice back in the day, when we actually used to hold like audio files as hard files and didn't stream them. It's a really, really lovely, lightweight sound player, which is why we chose it. It literally just does play sound files. But this wasn't the best thing about Winamp. The best thing about Winamp was this. It had a visualization engine. So you'd play your music, and you'd fire up this engine, and it would show you all these amazing visuals that went in time to the music. This was probably the most influential thing of any VJ of my generation. We probably just used to sit there going, oh, wow, wouldn't it be cool if we could make this? This is amazing. Like, it's just visuals going in time with the music. This is great. So I'm going to take you through the techniques that I have used to kind of try and recreate the idea behind this within a browser. So the first thing that we need is audio, right? And we've got this with the Web Audio API. Now there's 4 main ways to get audio with the Web Audio API. We can create a sound, so we can create an oscillator, which is essentially creating a sound wave. And that's a way to create sound. We can add sort of effects afterwards, and we can change volumes and panic and all this other lovely stuff we get the audio API. But that's the first way. We can grab it from the DOM. So we can get it from an audio or a video element, and we can pipe that into the audio API. We can stream it from a media stream source. We saw this with Soledad earlier. We can just pipe it in from our camera or a microphone, and we could stream it into the audio API, or we can actually buffer it from a file. So we can load a sound file into the audio API via a buffer. The latter two are probably, or the latter three are probably the ones that we kind of want to look at for when we want to analyze, which is the next bit. So 2 ways.
Regulators.
Any
You
excuse
regulate
to play
any
this.
stealing of his property. We're damn good, too. But you can't be any geek off the street. Gotta be handy with the steel, if you know what I mean. Earn your keep.
Regulators! Mount up.
Oh, great. So that first way, I was loading in a sound file, and I was analyzing that sound file. This second way is picking up on my mic. So it's actually analyzing the sounds of my voice going. And that's the next bit that we need. Once we've got sound, so that was almost the easy bit, the next bit we need to do is analyze it, right? I'm not allowed to talk about analytics. So I kind of failed on the first one already, but it's fine. We've got like 3 more. I can totally get this talk done without actually getting all this wrong. It'll be amazing. So yeah, we need to analyze sound. This is probably the most important thing of the stuff that we're actually going to do. And we can do that with the Web Audio API as well. So there's an analyzer node. If you don't know much about the Web Audio API, it all works within nodes. You have like input nodes, you have modification nodes, you have output nodes. So the input nodes were what we were talking about earlier with like loading sounds in. Modification nodes are things like the analyzer node, you've got volume changes, you've got filters, there's lots of things you can do with that sound. And then there's output nodes, which for the majority of the time is your speaker. And you kind of string all these nodes together, and that's how you kind of use the audio API. So the analyzer node gives us frequencies, and it analyzes frequencies. So frequencies are like tones, so it's like low to sort of high. And it goes from 0 hertz to 20,000 hertz. So that's the range that the human ear hears. You might not hear 20,000 hertz when you get a little bit older. I know that I probably can't hear 20,000 hertz. And actually, music doesn't really go up that high, so you'll be fine. But that's what the analyzer node gives us back. And it gives us back to us in an array. So we create an array, we give it to the analyzer node, and then that gives us back the volumes of each of the frequencies that we can make that array whatever size. And the bigger that we make the array, the better resolution of analyzing that we get. So it's pretty simple to make something like that once you've got all that information. This is just a bunch of I elements sitting in the DOM. And all I'm doing is looping over that array and looping over the I elements and attaching one part of the array to each one of the I elements. And as the sort of velocity or the volume of each frequency is going up, as is the height of each of the I elements. It's pretty simple. That's it. But this is kind of quite powerful stuff because we're using the DOM, and the DOM's pretty cool. So I sort of started playing around just with this simple idea to start with, and we can add more stuff later. This is a pretty cool artist. See, super cool artist. It says it on the slide, so she has to be. Her name's Bridget Riley. I discovered her in Scotland earlier this year. And she does these like huge, big paintings, which are quite simple in effect when you look at them. They're sort of like, you can see them here. They're just kind of lines. But the way that she does it means that there's sort of movement through these lines. And when I saw them, I was like, oh, I kind of want to make those into visuals. So I kind of did that. This one's cool. This is just checkers sort of, again, it's just DOM elements. So we're just changing the width of those DOM elements based on like the sound. And I'm still doing that thing where I'm picking up on my mic. So this is picking up on the sounds that I'm getting and analyzing it and then changing the widths, like dependent on what frequencies that I'm passing it in. We can expand on that, so triangles, fadey triangles, and then bright triangles, and then fadey. But like, because we're using a browser and we're using the DOM, there's some other like great things that we have with that. There's some great, lovely CSS things, which is a great thing to talk about at a JavaScript conference. Transforms. So I thought it would be really nice if I could grab whatever was in the DOM and reflect that and rotate it around, and we could do some like symmetry, which would be great for like end visuals. So I did do that. So this again, it sort of flashes in time with the music. So if I go quiet, it kind of disappears, and then when I go loud again, it comes up. But it's just transforming. It's just grabbing. There's a function. It just grabs whatever's in the DOM and then reflects and rotates it around. After I built this, I thought, wonder if I could put a GIF in this. Yeah, we could do that. Cartoons, man. Always do cartoons with your viz. So this is just exactly the same code, and we're just dumping a GIF in, and it's just rotating and reflecting it around. Browsers are so good for this sort of thing. Other things that we get with CSS now are things like blends and filters, which are really nice. So this is very suited to what we do, and the opening that I started with earlier with these pictures of the speakers, these are using both blend modes and filters. So if you aren't aware, blends are sort of a transparency layer over your elements. If anybody has used Photoshop and used layer modes, you'll be very, very familiar with them. If you haven't, it just sort of adds a nice sort of veneer over like your foreground and your background. So you've got like mixed blend mode as a property, which you can put on your element. There's also background blend mode. If you've got sort of background images, you can use them in that way as well. There's also filters. So the pictures of the speakers actually do use a sort of contrast filter, which is picking up on the analyzing and making it stronger and weaker as it goes. But the filters are very good for things like images, especially good for video. You've got things like grayscale, inverting, blurring, like all this kind of stuff, which is, it's really good when you want to put that in time with the music. I was talking about CSS, and I'm going to carry on, but wait for it. It gets more interesting. Custom properties. Right, so we have custom properties in CSS now. So this is sort of like variables. They're not quite exactly the same, but they are. You declare them at the top of your CSS file, and then you can use them throughout your CSS, much like you would with a preprocessor. I'm sure we're all familiar with it. So something like this uses a lot of the stuff which I just described. So it's just sections with I elements in, and then I've rounded them off, and then I've rotated them around. But the width and the height of them is changing, like dependent on a custom property that I've set. But I'm changing the custom property with JavaScript, and that's going directly into my CSS. This is kind of fun. This is JavaScript all up in your CSS, right? So this top bit is the CSS, so we're declaring this variable like -- level, and then at the bottom here, this document.element.styleset property, I'm actually passing in one of the frequency velocities. So when that gets louder or softer, it's actually changing the level and actually changing my CSS directly. I like someone's doing this at the back. I'm like, thank you very much. So that's really, really interesting. Now, there's one thing to note about this technique, and I don't know whether you realized, this is actually a GIF, because to put it within my slides and to actually have it running is really, really hard because it's not very performant. What? I'm not allowed to talk about performance? Oh, operational excellence. Not allowed to talk about performance. Okay, 50% down. It's okay, we'll still be all right. Custom properties, when you're using them with sort of widths and heights and you're constantly polling them, they're not very performant. I found this out the hard way. And I was talking about this with my friend, when I was chatting to my friend. Not allowed to talk about chat ops either. Yeah. I've got one more to go. I'm not allowed to talk about orchestration. I think I can get away with this. I think I can end the talk with just orchestration left. I think we'll be all right. Anyway, this is Ben. This is my friend Ben. And I was talking to him about performance because I sort of did this interactive installation at Conf Brazil, and there were 1,500 attendees, which is a lot of people to do something interactive with. It didn't really work. Chrome doesn't like 1,500 people connecting to it. So he kind of helped me out, and he went through my code when I got home. And he was doing some really, really cool stuff with D3 at the time. We had a talk from Nadia yesterday about D3, so it was really, really interesting to see his take on it. And it's really good to talk to your friends about stuff and show them your code, because then they introduce you to other things, and then your whole world kind of expands, which is cool. D3, he kind of introduced me to this idea that it might be better for some of my visuals as far as performance goes. So D3 is really, really good at data. I'm using a lot of data. I'm doing a lot of analyzing of frequencies. It's basically data. It's also really good with DOM stuff. So we use it for a lot of SVGs, which is on the list here. But actually, it's quite good just working with the DOM and making that performant. Also really good at maths. Super important if you're working with data. It does have a lot of sort of manipulating sort of methods and functions. So it was really, really interesting to start using it. This was my inspiration for my D3 set. This is a book called Super Graphic. It's all to do with, it sort of takes data from comics and graphics novels and sort of puts them in it's just a lovely book to flick through. It's just data visualizations from comics and graphics novels. It's really cool. But it's really interesting because it becomes really, really easy to sort of make things like this. They look really good when you've got a lot of bass. But this is just a really simple D3 example, and you're just moving it around just based on the frequencies. And then you do accidental animation, which is actually a thing. So this is one that went wrong, but actually it looks really nice. So I was super happy with that. And then this one's kind of a bit crazy. I kind of have to be a bit quiet. This one's dots. Yeah, it's really, I'm wondering whether my radius math is a little bit out. But as Nadie showed me yesterday, you can put, woo. Oh, really quiet. You can put blend modes on it. That was so cool. I'm so glad she showed me that. I was like, yeah! And it makes it go white when it's really loud. I can change the volume of the microphone. It's cool. And then we just have simple ones. Yeah, I quite like that. That'd be a really nice overlay for a video, I think. I wanted to talk just very, very briefly about the analysis that we're doing on the audio. This is probably the most boring part of the talk. We are creating a linear array of values from 0 hertz to 20,000 hertz. And most music will not go up to 20,000 hertz. It probably wouldn't even go up to 5,000 hertz. Plus, we have a linear array. So we kind of need to do some maths on that analysis. We need to break that array down. We can probably take the first quarter of those numbers, and we also need to spread it out. It's a linear array. Music is not linear. Music is logarithmical scale, right? If you actually play a piano and you go from one octave to the next octave, for people that aren't musical, that means sort of you're going from like the same space to the next space to the next space. You're actually doubling frequencies. You're not going up like 1, 2, 3, you're actually doubling. That makes it a logarithmical scale. Now, I've only just started thinking about this. So I'm going to be doing some work around the maths and hopefully making them a lot easier to use for the analysis, which could hopefully mean that things like beat detection, low frequency, mid frequency, and high frequency detection within the actual sort of software and sort of visual ways could be a lot easier. I sort of did some pseudo stuff on this one, and you can see it's spread out a lot more. So I've kind of broken this array down. If we jump back up to this one hasn't, and you can see how it's kind of bottom heavy. Almost. So the red on the bottom there's a lot more activity in that end of the array, which is fine for visuals, I think, in the short term, but I think if we actually want to do some proper analysis, and like I said, beat detection, we're going to have to sort of think about that a little bit harder. This is only just something I was thinking about in the past couple of days. Cool. We got visuals. If you want to see more of these, I did Codevember this month, and there's a big collection of them on CodePen. Including some of the ones you just saw then. So it's kind of easy to create visuals, right? We can all agree that was fun. We've got some analysis. We made some trivial cool stuff to it. But we kind of want to control them as well. And we've got a keyboard connected to our laptop, but that's not really exciting. There's a web MIDI API. That's more exciting. So I'm going to do a quick background in MIDI so we all are aware, because I'm sure there are some people in the audience that don't quite know what MIDI is. MIDI is not 80s bleepy music. MIDI is a data protocol that came around in the 80s because there was a rise of electronic instruments in the 70s. And so industry experts and music manufacturers got together and they said, wouldn't it be really, really nice if all these instruments could talk to each other? Because they're all electric. You would think that actually we could find a protocol where they could all talk to each other. And not just to each other, but go into recording studios and talk to recording equipment as well. And that's how MIDI came around. The first spec was General MIDI 1. It's kind of moved on now. We have General MIDI 2. There's a lot of other specifications as well. But for the most part, that's what MIDI is. It's just passing numbers back and forth between equipment. And this is the crux of the web MIDI API as well. If you plug a MIDI instrument or controller into your computer, you are just essentially, if you run the code, getting numbers, which makes it quite powerful if you want to hardware enable your browser. I would recommend playing with it if you want to. One thing to bear in mind is this is a MIDI instrument. Orchestration for instruments. Fine, okay. This is literally like the most useless talk ever right now, but okay, we'll go with that. This is a MIDI instrument. Okay, MIDI instruments have onboard audio. I'm sure you've all seen one of these. This is a keyboard, you play it, plays music. It probably has, these days, probably has a USB port. So you can plug it into your computer, and if you run code in the browser, you can actually feed back MIDI information into your browser for a normal musical keyboard. That's cool. The difference between that and something like this, which is a launch pad, is this is a controller. There's no onboard audio, right? For the most part, these are slightly cheaper than instruments. You can actually pick up keyboards pretty cheap these days, but for the most part, these are just boxes. This is my handbag MIDI controller. I didn't put it too far away from my computer because it's Bluetooth, so it might lose connection. This is a Bluetooth-enabled one, so there's no USB connection, but it should be still connected to my browser, fingers crossed. And it's just buttons. There's a nice little crossfader on here. So I can kind of use it with my visuals, please let this work, to kind of crossfade, there we go, from one visual into the next visual. I'm hoping we can kind of all see this at the back. So all I'm doing is just polling these values. This is a CC controller, and it's just passing me numbers. And when it gets to one side, we're showing one visual. When it gets to the other side, we're showing another visual. And then we can kind of stop it in the middle and kind of show both. Which is super handy if you want to mix visuals live, right? There's some nice effects on the buttons as well. So we can like flash invert and things like that. You can set these buttons up to do whatever you want. For the most part, I generally set them up so I have different sets. So I load different things into the divs, I have some effects, and then I can crossfade between them. Super handy bit of kit to have. And it fits in your handbag. Whew. So that's how we control the visuals. Great. But is this at all real? This is such a hobby talk, right? This is me. I have a pocket projector. So I created like an usherette tray bag that opened up with my laptop and my MIDI controller in, and the projector projects out from the bottom. And this is me projecting onto the streets of my city last year. We did it at Christmas. It's cool. I'm just playing music, just walking around the streets, just projecting. I love the fact that you guys are laughing. There's an article about this on 24 Ways, if you're interested in it. It's like how I made it. But really, though, I started a collective called Live.js. So this is all different people doing live things built with JavaScript. Matt is here today. He's doing some stuff tonight with some stuff he built that does live music. I'll let him talk to you about it. Tim does some stuff with LEDs, which is amazing. Martin controls lights with JavaScript. It's great. Like, they all do their own thing, and it's amazing. Last week we were at JS Conf AU. I think Thomas is here in the audience. Yeah, there he is. He's waving. He organized. He invited us to do it. We did a gig. We're doing gigs. It's not, I know, you think this is a hobby. No. We'll be doing some stuff tonight as well, so hang around. This is how real it is. We have a GitHub organization. Defo real, right? When you've got a GitHub organization, think, shit, it's getting real. I am actually coding my own software based on all the things you just saw. So the analyzing music and making that better, controlling it with MIDI and being able to hook up different MIDI controllers to it, including things like video. There's a lot of video in my sets these days, as well as all the animation stuff which you just saw in the talk. I have like two versions. I have a really, really hacky version, which I have been just using as a sketch pad for the past sort of 18 months, which is on my GitHub if you want to look at the code, but I wouldn't. It's not nice. I'm rebuilding the software, and it will be on this organization if you want to see it. I'm not going to show you a demo within this talk, because Matt is doing some stuff later tonight, and I will be doing projections for it for the after party. So if you want to come up and see and chat to me, I will be here. There will be projections on this projector. It will be amazing. There's one last thing I would like to address. Most useless talk ever so far, right? But for the keen-eyed among you, duct tape. Not actually holding the bag up. The harness really works. There's duct tape taping the laptop to the bag. Ben's on a bike. Yes. There's a workaround in this. Oh, didn't I get a down for that? Damn it. There's a workaround in this code. I tried to do maths in the CSS. Don't do maths in CSS. I know we have calc now. It doesn't work. Keep your maths in JavaScript. It is much better for it, even with floating shit, honestly. And also, I got coffee. Most useful talk ever. Thank you very much. I have been Ruth John.
Thank you.
It's okay.
Yeah.
Come and see me tonight.
Cheers, mate. What's really fun about Ruth, actually, is I met her in middle of nowhere, Germany, in May, and we were chatting over a beer, and she said, "Oh, I actually met this other great Australian." I think she said rubbish, but she said, "I met this great Australian. Maybe you'll know him." And it
There's only 8
turns
million
out,
people here.
yeah, it was Glenn Madden. So we had a bit of fun, and we hung out there, and that was great. And as you can tell, Ruth's pretty cool person. So thanks for coming all the way out here. Tonight's going to be real fun too. So stick around for that.
Yes, it will be. Stick around.
Yeah.
Thank you for having me.
Thank you for coming. Okay, so we are a little bit behind schedule. Sorry, we're late. We're running late. So we have a break scheduled now, but instead of going out and having a full break, it'd be much better if you just want to stretch your legs, grab a quick drink, something like that. If you want to stay right here, do that too. That's cool. And we'll get started in, 10 minutes. All right? Thanks.
Whoa, that was really loud. Hello, everyone. Hope everyone had a short break, stretched their legs, got drinks, comfortably seated. I actually cannot believe this is the last talk. I do not know where the day went. I know if you do, but I literally don't. First of all, I would like to mention a trigger warning, as this last talk of the day has mentions of abuse and harassment. And I really am so stressed. I know that she's very stressed, but I'm also really stressed because it's absolute privilege to be able to introduce someone who has probably the most accurate, thoughtful, and thought-provoking analysis on the tech industry in our community. And I think it's really, really important that we all see this talk and we are really carefully paying attention to what she has to say to us. It's really, really important. And I couldn't be happier to have her on stage to close this conference. I could not be happier. A team lead at Travis CI, straight from Berlin. Give it up to Lena.
Thank you. Hello, JSConf. How are you doing? Did you have a good day? Did you have a really good day? I would like to ask you to give a big hand to the organizer for putting together this fantastic event. Thanks very much. And thanks for the beautiful intro, Carolina. So my name is Lena Reinhardt. I'm at LRNRD on Twitter. It's very hard to remember, so I got it on the slides. And I'm leading the design and platform engineering team at Travis CI. So if you want a Travis sticker later, come find me at the party. I'm also a writer, a photographer, and, well, I'm a speaker, which also brings me to the reason why I'm here today. This is a talk about debugging, about the tech industry, and most of all, this is a talk about you and me. Let's start by talking about software bugs. What are bugs? Bugs are errors, flaws, or failures in software that cause it to produce incorrect, undesired, or unexpected output. A bug can be many things, like a performance problem, configuration issue, an issue with functionality, or a system error. At all points in our development cycle, we can end up with bugs in our software or systems. So we need to debug it. We need to find and resolve these defects. And with increasing complexity of our software and systems, debugging becomes more and more difficult, like with these bears here. The system that I want to talk to you about today is more than code. It's a complex system that's grown over many years, a system that we're all part of and that we all contribute to. The system is the tech industry. In order to debug a system, we need to understand it. And to understand a system, there are a few things that we can do. We can look at each individual component of the system. We can look at how all components interact, and we can look at the system output. So let's take a look at the tech industry as a system, at its components, their interactions, and output. I'll show all of that to you in a simplified Venn diagram. The tech industry has a few major components. We have communities like free, Libre, and open source software communities. And here you can see one sample community. There are also companies, from a few people who just launched a startup to giant corporations. And like any system, the tech industry doesn't exist in isolation. With all its components, this industry is also part of our societies. And then there's one more component, one human like you and me. You and me, each of us, are one individual component in this system. We are the smallest entity, but our role is important. All of us are part of communities, companies, this industry, and all of us influence them, and we are influenced by them. Some of us contribute to open source projects, and software licenses determine how our work can be reused and distributed. We also work on products and projects in companies, and
These companies determine how we work, what we work on, and how we're compensated. We also decide how systems are designed and which code is written. And our own social norms determine the way we think and the way we make decisions, and so forth. But a system is more than just the sum of its parts. All these components are intertwined and they accumulate characteristics of other components. And together, all of them influence the tech industry as a system. And they produce output. This output is the software we build. And each and every one of us influences this output, no matter if we're aware of it or not. Who of you all is a software developer, designer, project manager, or works on software in any other way? Hands up. That's almost the whole room. Who of you has ever harmed a user of your software with something you did? It's probably 20 people or so. And who of you is not sure if you've ever harmed a user with something you did? We can never know for sure, can we? All of us need to care about the impact of our work as individuals and as an industry. And here's why. As a still relatively young industry, we have accumulated a massive amount of influence within a very short time. Our work has impact, and with impact comes responsibility. These impact and responsibility are constituted through 4 major factors. First of all, there's ubiquity. Software systems are ubiquitous in all aspects of public and private institutions. Software is running on everything from computers to juicers, smoke detectors, and washing machines. Software systems also lie at the heart of modern decision-making. Algorithms decide how much our insurance will cost us, whether we get credit or not, and whether we're potential criminals. But do we really know where our software is run and what it's used for? Our impact also comes with our role and with scale. For most tech companies, the world is our addressable market, and there are only few geographic constraints for where we can do business. We can build things for a lot of very different people. But do we really know what all users of our software are like? Impact and responsibility also really comes with our role. Software development is an act of representation. It means we need to provide solutions to actual problems that people are facing. But do we know what people really need? And do we even want to know? And our impact, lastly, comes through dependency. People rely on and trust software, not because they choose to trust it, but because they usually don't have a choice, because they depend on it to achieve what they need to achieve. If people don't use social networks or messenger apps, access to friends or family becomes more difficult. If websites aren't accessible, disabled people can't get access to information that they need. But how do we all handle the fact that people depend on us? Ubiquity, scale, representation, and dependency. All these factors lead to the giant impact of our work and our responsibility for it. So what does our software do to people right now? What does our system output as an industry look like? Software can have positive impact on people's lives. It can help people connect with others, get access to information or support, help them get where they need to go, and so much more. Software can empower people, and that's a great thing. But then there's the other side of software, the other side that we rarely think about. Software enables. It enables harassment and abuse. Any software with human interactions is a greenhouse for harassment. This includes important networks like Facebook or Twitter, and any other software with built-in human interactions. 40% of adults on the internet have experienced online harassment. Widespread harassment and abuse have made these important technologies unusable for many people. Numerous people, like people of color, queer, trans people, activists, and many more, had to leave these platforms because the harassment literally made them sick. Software meets users' needs, but only some users' needs. When Apple introduced its HealthKit app in September 2014, you could track everything there. Measurements, fitness, nutrition, sleep, vitals, but not your period. It took Apple 1 year until they finally introduced period tracking for HealthKit. And as a study from earlier this year showed, virtual assistants like Apple Siri, Google Now, and Microsoft Cortana redirected users to help when they said they had a heart attack. But none of these assistants were able to recognize what it meant when a user said that they're being abused. And 1 in 3 women worldwide is abused at some point in her life. Software also recognizes people, as long as they're white. Face detection software in cameras can warn people when they're blinking. But it also asked Asian people if they were blinking, no matter if they were actually blinking in portrait photos or not. Other face detection software in webcams completely failed to even recognize the faces of black people. Flickr's photo tagging algorithm auto-tagged the photo of a black man with the words animal and ape. And recently, 6,000 people participated in an online beauty contest. These 6,000 people were from 100 countries worldwide, and all photos were judged by an algorithm. Out of the 44 winners of this contest, almost all were white, a handful were Asian, and only 1 person had dark skin, although many people of color had submitted photos. And when our software is learning, what does it actually learn? When Microsoft launched its artificial intelligence chatbot Tay 6 months ago, the bot was supposed to learn human speech patterns. Within only a few hours, the bot started posting racist, fascist, sexist, homophobic, and other tweets, and it started harassing Twitter users. And when our software helps people get access to information, what kind of information is that? Recent reports found that false or misleading content, which reinforces people's existing beliefs, received stronger engagement rates on Facebook than accurate, factual content. Algorithms became an enforcer for confirmation bias. And lastly, software empowers. It enables privacy violations and distributed denial of service attacks, or DDoS attacks. The so-called Internet of Things is a privacy nightmare. Routers, connected baby monitors, heatings, window blinds, webcams, TVs, toasters, fridges, vacuum cleaners, and many other devices are in people's homes. Estimates say that by 2020, there will be more than 20 billion connected devices worldwide. Many of these devices are unprotected, buggy, have built-in backdoors, they're open doors to hackers, and they're used for DDoS attacks. And all of these, this is a summary of the examples I just mentioned, all of these are just very few examples of what software does. Yes, there is software that does great things for people, that empowers and enables them. And many of these problematic examples I mentioned earlier have been fixed in the meantime. But none of these problems should have been there in the first place. And such issues like these keep happening. There are far too many, far too bad examples for the harm that we do as an industry. This industry is a broken system, and it produces broken output. Output that has severe consequences on people's lives. And all of us need to stop ignoring that. We need to understand every piece of software is the result of a judgment call. Every button, every word, every pop-up, every ad, every line of code. Right now, through our software, all of us are forcing our own prejudices, norms, assumptions, our racism, sexism, and our narrow views of the world on the people who use it. The software we build systematically ignores people and their needs. With the software we build, we are normalizing racism, fascism, sexism, homophobia, harassment, misinformation, and surveillance on our platforms. We are creating new realities in which all of these things are the new status quo. And that is a serious problem. We are the industry that's building self-driving cars and planning Mars missions. And we haven't even figured out how to make sure people's vacuum cleaners don't join botnets. As an industry, we love talking about the next big things that our technology could do. We love thinking and talking about artificial intelligence, self-driving cars, and Mars missions. And all of these things are great, and they're important. But by building software, we create environments. And all of us, we are the ones who are making the rules for these environments, for how they work and for whom they work. And at the same time, we lack answers to fundamental questions of the ethical implications of our work. And most of the time, we even refuse to ask ourselves questions about these implications. Building software is so much more than typing code into an editor. We are enablers. Enablers for empowerment of people and enablers for harassment and abuse. This means that we need to understand social and ethical issues. No matter if we care about them or not, ethics are built into everything we do, so we need to be deliberate about them. Ethics are moral principles that govern our actions. There are limitations for how ethical we can be in an industry that's part of capitalism, but that also means that we need to be even more aware of what we do and how we do it. Ethics in software development mean thinking past current trends and anticipating every future utilization of what we build. And as an industry, we don't care about ethics enough. And here's why. First of all, ethics are complex. They're pretty obvious in some cases like software theft or deliberate invasions of privacy. But in most cases, ethics are far more subtle. Ethics also aren't part of computer science curriculums and not built into our processes in our companies and communities. Ethics aren't a checklist, and we don't make room for thinking about them. We also don't care about ethics because ethics aren't automated. We have automation in place for showing us the technical limits of our work, for when our tests are failing and for when servers are reaching their limits. But we have no built-in boundaries for violations of our users' rights. And lastly, we refuse to understand our role. We all know the stereotypes. The stereotypes that picture us as a bunch of unathletic, uncreative loners that wear glasses, work all night, all day from a basement, probably their parents' basement, with no human interaction, whose diet is based on energy drinks and cold pizza, and who have no social life. This is actually a stock photo that I got out of that description. And all of us know that these stereotypes are wrong. But we act like they're still holding true. We are still behaving like we're just a bunch of people hacking on some cool stuff, when in fact all of us have become so privileged, so powerful, when our companies are among the most influential and most valuable in the world, and when our work has such fundamental consequences on people's lives. Our scientists have done things which nobody's ever done before. Yeah. But your scientists were so preoccupied with whether or not they could that they didn't stop to think if they should. It's probably one of the most famous quotes from Jurassic Park. As people in this industry, we have power, and with great power comes great responsibility, and that's a platitude, but we even fail at acknowledging that very simple truth. Right now, all of us are so preoccupied with whether or not we can that we don't think whether we should. Every one of us has impact on our companies, communities, and this industry, and on the software we build. No matter who you are in tech, at what point you are in your career, or what you're working on, you can make change happen. And we need you to make a difference. The people using technology need you to make a difference. Use the power you have for good. Use your power to debug this industry and to make sure it generates meaningful output. Over the next minutes, I'll show you 5 things you can do to debug the tech industry. Step 1 to debugging the tech industry is understanding ourselves. As people in tech, most of us are extremely privileged. Having privilege means that we can exist in our society and this industry with ease and gain influence without scrutiny or suspicion, which gives us advantages relative to other people. Our privilege comes from factors like our gender, ethnicity, class, education, upbringing, physical and mental health, and many more. Privilege is the human version of, but it works on my machine, or it works in my life. Privilege puts us in a position where we don't see problems that our work causes and don't see problems in this industry because we're not personally affected by them. We need to work through our privileges. We need to understand that not everyone has what we have, that not everyone has the money, electricity, high-speed internet, education, and so many more things that all of us are just used to. And we need to understand that not everyone has the same privileged position in society that many of us have. We need to understand that what's safe and easy for us is not safe and easy for many other people. And it has to become visible in our work that we understand that. We need to question our beliefs, our reasoning, and our assumptions. And we need to stop assuming that everyone is like us. In our work and interactions with people, we also need to address our biases. Biases shape our decisions, and they're based on our stereotypes, assumptions, knowledge, and cultural norms. We need to be very conscious and deliberate about how and why we make decisions, and about how we interact with people. Our privileges and biases are baked into everything we do, and they contribute to the horrifying output of the tech industry. Same goes for our collective lack of empathy. Having empathy means being able to relate to another person as though they were us. And as an industry, we are lacking empathy. But empathy is the main determinant for how usable, how safe, and how meaningful our technology is for other people. As people in tech, empathy is our responsibility. Step 2 to debugging the tech industry is we need to care about our work and its impact. We need to understand that we are not neutral, that our code is not neutral, our algorithms are not neutral, our technology is not neutral, our work is political. We need to learn about ethics and the ethical implications that our work has on people. And we need to make room for thinking about ethics in our companies and communities. And we need to ask questions that challenge the status quo. Yesterday morning on my way here, I got coffee from a place around the corner. And this is what it said on the cup. If you have any questions, we will be happy to provide full and detailed... Oh, sorry, that was completely wrong. So I'm doing that again. If you have any answers, that's where I'm going. We will be happy to provide full and detailed questions. Else the rest of this talk is not going to make any more sense. So I saw that and took a photo of it. You can see the CSS Conf sign up there, actually. And like the people at this coffee place, and probably also this cup of coffee, I don't have answers for you. But over the next minutes, I'll pose a number of full and detailed questions. Questions that challenge the status quo. I want to encourage you to think about these questions and discuss them with the people you work with, and here are a few of them. When we're working at companies or when we're part of communities, who's working there? Are there people who are different from us? Are our organizations inclusive? Are the people working at our company as diverse as the user base of our software? If not, why is that? Do our organizations have ethical guidelines for how they work and who they work with? When we develop software, do we move fast and break things? Even though that can mean we expose our users to data breaches, bugs, and security issues? Does our software actually do what it claims? Or do we trick users into doing things that they wouldn't want if they were aware of it? Do we really think through whether and how our software could be misused? And when we fix bugs, do we fix bugs of high-paying customers first? Or do we treat them all equally? And how do we decide whether a bug is serious enough to be fixed? Is our software accessible? If not, why? And who do we exclude by not making it accessible? When we build interfaces and algorithms, which information do we display to people? Is that information factually true? What do we allow users to see in an offline state? How much data do our apps consume? And what does that mean for who can actually financially afford to use our software? When we collect user data, do we only collect what we really need? When we store data, could this data be used to track or profile people like protesters or activists? What could happen to our users if our data is obtained by someone with bad intentions? Which risks are we exposing our users to? And when we keep log files, are they adequately protected? Who has access to them? And when we say we delete data, do we actually destroy it? What do we do when we're asked to hand over user data to authorities like governments? Regulations that are currently in place to prevent unreasonable demands can change any time, and it's a safe bet to say that they will. What will we do when we receive demands to hand over data? And lastly, do we consider that paradigms around the software we build, the data we store, can change any time? In many countries across the globe, fascism is on the rise again. Knowing that, what will we do? All of these are the questions I just asked. And these are just a few of the questions that I want to encourage you to ask yourselves. These questions are important. We need to discuss them with our coworkers, our managers, the people in our communities. And we all need to work on finding answers to them. This is what the second step to debugging the tech industry means. We need to care about the impact of our work, and we need to ask questions that challenge the status quo. This is urgent because people's lives are at stake. Step 3 to debugging the tech industry is we need to rethink the way we work. The output of our work is not just about an app we work on. It's about what it enables people to do, what it empowers them to do, and what it exposes them to. We need to approach our work holistically. We need to understand which environment our software creates and how this environment impacts its users. Therefore, we also need to actually understand the people who use our software, and we need to get better at communicating with them. Step 4 in debugging the tech industry is every one of us needs to foster change in our companies and communities. This industry has an enormous problem with diversity and inclusion. In Europe and Australia, 70% of people working in tech are men. The numbers of women, people of color, lesbian, gay, bisexual, intersexual, trans and queer people or non-binary people in tech are incredibly low. Diversity could be our greatest strength. Software development is an act of representation, and to adequately represent the users of our software, this diverse user base, we need diversity in our organizations. But all of us are failing at this representation role right now. We need diversity in our industry to show that we respect all our users, their needs, their value, their safety, and their humanity. This is why every one of us needs to support diversity in our companies. We need to make sure that our companies hire people who are different from us, different in genders, ethnicities, backgrounds, skills, upbringing, and so many other factors. We need to get diverse groups of people into tech, and we need to make sure to include them. We need to make sure that our workplaces are inclusive for diverse groups of people, and that our communities are safe, respecting spaces for everyone. Diversity and inclusion are our responsibility towards everyone in tech and towards our users. Step 5, and the last step for debugging the tech industry. We need to support others who work on debugging this industry. Support activists and organizations that work on diversity and inclusion in tech, organizations that care about mental health and social justice in this industry, organizations that work on privacy tools and user advocacy. We need to give our time, knowledge, technical skills, and our money to support them. And we need to become allies. We need to stand with people and organizations fighting for change in this industry. GuideToAllyship.com is a fantastic open source resource by Emily Lamont about how to be an ally, and I want to strongly encourage you all to read it and to become allies. To summarize, in order to debug the tech industry, we need to understand ourselves and our role, develop empathy, care about how we work and the impact of this work. We need to ask questions that challenge the status quo, and we need to foster change in our companies and communities. All of us need to do that, and we need to do it right now, because this is about the future of technology. This is a talk about debugging the tech industry. And debugging the tech industry is about you and me. What we have now is a chance to build something bigger, something that lasts. What we have now is a chance to debug the tech industry and make it a better system that is about justice and equality. We need to make this industry a better place for everyone, so that we can build technology that is for everyone. Technology that enables, empowers, and helps people. Technology that is meaningful for people and that solves many of the problems that humanity is facing right now. We all need to stop hiding behind our screens and start caring about what we do to people. Now is the time to debug the tech industry. This is the biggest and most important task that all of us have as people in tech right now. And the question is, when we debug the tech industry, will you join us? Thank you.
Right in the feels. Can't really say much to follow that up. But I will bring up my whole team, everyone in blue. What a group of people. Yeah, super proud of these people. They've worked super hard, and I think we can all say that it was worth it. What we're going to do now is we're just going to wrap. We're going to keep it real simple on everyone. It's the onions. I was cutting out the back there. All of our speakers, do you want to come and join us up here? We'll come and get a nice photo for everyone. If any speakers are in the room, any guests. Come on, let's do it. We're going to get Ben down the back there again. Nice fun class photo. Everyone get in real close. Come out front, everybody.
Everyone in the back, please come down the front.
Hi.
You're here with us. You're here with us. Come on.
Tell people at the front.
Tell people.
Come on, quick, Jake.
More? Why were you doing it?
Yeah, this is yeah, okay.
Yeah. They're just waiting to see what happens next.
Everyone. All right. Firstly, let's give a huge round of applause for all of these people here. Thank you so much. We have people from every corner of the globe here, and Australia is not a close place. So thank you so much for everyone coming and for all your time and all your hard work. We really, really appreciate it. What we're going to do now is we're going to do a class photo, and that means with all of you. And live streamers too. It's going to take you 30 seconds longer, but you're going to get in here too, if that would be appropriate. While you're all coming up here, come on everybody, come on, let's do it. I want to say a huge thanks to all of our sponsors. We literally couldn't do it without sponsors.
Charlie, piggyback.
Other people also should be in the front.
Ruth, come on. We need you.
Everyone has to squish.
Everyone's got to squish in.
Then tell people to come to the front rather than stand on the sides.
Oh yeah, and if you're at the sides, just come to the front. Come on, we got plenty of room over here. It's great.
Wearing a red lanyard, take it off.
Yeah, we'll blur them out. Ah, okay. All right.
Squish.
Got to squish everyone.
People from the side. People from the left-hand side.
All right. ECMAScript. It's actually ECMA. Well, actually, it's ECMAScript. Okay.
Thanks for the insight.
Thank you. Yeah? We're Thank you, everyone. Thank you so much. Put your hands up.
Oh, God.
Do we still have the microphone on? I do. And don't forget, the night isn't over yet. If we just head straight outside, there are light refreshments. And there's dinner. And then there's entertainment.
No, I don't want to talk, man.